Hi, David. Would you be okay if I just take presenter for a while and check that all the slides are in place? I uploaded them, but I just like to check.
Hey, Sumit. Are you already uploading the slides?
Hey, John. I think it's already done, so I'll just give you a presenter and you could also check.
Sweet. Thank you so much.
Sure.
All looks great.
Okay, I think we're only missing session 8
Yep.
slides.
They're going to do a screen presentation for that. So.
Okay, cool. I did add some sort of template in the shared notes thing, and I'll take care of the notes. Is there someone already designated for chat monitoring?
I can try to help with that.
Okay, cool. Thanks.
I'm going to grab some coffee.
Hey, John, do you hear me?
Hi, Todd. We can hear you fine.
Okay, good.
Yeah, it's all good. Hey Kareem, do you want to do a quick audio check? If you're trying to say something, it's still not audible.
One, two. Is the audio good here?
Oh,
Hey,
that's
we're
good.
hearing you now.
It is good now? Okay. All right. Let me just change the slides behind me here. All right, I think we are sort of set to start here. So let me go ahead and get started. My name is Kareem Yagmor, and this is the Android Micro Conference for Linux Plumbers 2021. So welcome everyone. Good morning, good evening, good afternoon, whatever it is for you. We all have our different time zones. So much like every year, this is a good opportunity for the Android community to sort of sync up with the rest of the Linux community. This year has a different sort of focus, or I should say theme. Previous years have been sort of more of a, an expose of what Google's been up to and sort of an opportunity for the community to ask questions. This year is slightly different, wherein we actually are trying to solicit sort of more a joined effort of reflection on where things should move forward. So we invited key members of the community to come in and sort of discuss different topics, as you'll see as part of the schedule. All right. The other thing that's a bit different here is the slots are 20 minutes instead of 15. I mean, not a huge difference, but still, we've had in past years sort of run up to the limit there of the 15-minute mark. So being able to have these additional 5 minutes is going to be welcome. So let me quickly run through some of the preparation slides here that we got, as well as also a sort of just to give you a few caveats and instructions as we go. So this year we've got a number of different sponsors, and we'd like to thank them for their support. They're absolutely needed for this event. So Facebook, which is a diamond sponsor, IBM, which is the platinum sponsor, and if I can get that on the screen here, sorry about that. All right, there we go, sort of coordinating two screens. Gold sponsors are and Microsoft. Then we've got silver sponsors and speaker gift sponsor and t-shirt sponsor, and of course the conference services, which are offered by Linux Foundation, which has been supporting Linux Plumbers for quite a few years. All right. We'd like to thank the chairs and the committee for all their work. I mean, they've been doing a fantastic job for bringing this together through the years. And you know, some of these folks have been long serving here for on Linux Plumbers. All right. So, of course, you know, the conference is supposed to be done with respectful sort of environment. So if there's any abuses or anything like that, please bring them back to the community, to the committee, and we'll take care of them in due time. One thing that we wanted to sort of just give you a heads up, there's been a slight swap of presentations between Rust and speculative page faults. So if you had sort of scheduled yourself for attending those, keep that in mind as we go forward here. Okay, so for those of you who have not attended the previous one, there's effectively moderators, which is myself and a couple other folks, presenters who will be presenting, and then attendees. We'd like you to keep your mics off and cameras off unless you need to speak. I told you about the 20-minute slots. They will be hard enforced, so please try to keep the conversation going, and we will sort of call you on that if you sort of go above the sort of 10-minute mark. In a rather firm fashion. We will swap slides at about the 17, 18-minute mark. I'm about to finish talking myself to hand it off to Todd, who will be doing the first presentation. They will be off on Friday, which is now part of the official schedule. So we were still sort of waiting on this in last minute. So that's been taken care of. As you sort of finish your presentation, we'd like you to take notes because that's going to be required for moving forward, right? And that's pretty much it from my side. Todd, the ball is all yours.
Okay. I think, John, you're switching the slides.
Yeah, I no longer have presenter here, so somebody else is you are, I think, and the slides. There we go.
There we go. Okay, so as Kareem said, we've changed the format to be more discussion-oriented, more in line with the rest of Plumbers. However, this first talk is more along the old lines and more of a status update because we did want to start off giving an update on what is the kind of the big changes that have been going on. It's a multi-year project from the Android kernel team at Google. And that's the GKI, the generic kernel image. So my name is Todd Chose. I'm the kernel lead for that project. And so we've been talking. I was somehow getting muted. Hopefully you heard what I said so far. So we're going to give a quick status update. And then we probably won't have much time for discussion. So if you do have questions, we can take them in the chat, or we have a birds of a feather session on Friday at the same time where we can go in depth on any questions you have on any of the topics today. So with that, we'll start. So this is the architecture slide. We've showed this now for a couple of years. That sort of describes what GKI is. We have what we call the generic kernel, which is really the core kernel minus modules. And the big focus has been to get all of the SoC hardware specific code out of the core kernel and into separate modules so that we can get it as clean and generic as possible. And you know, from past years' discussions, you probably already know that what actually ships on an Android device in the past has been a device kernel with changes that come from the Android team and from a reference kernel that we maintained, and then changes from an SoC vendor, and then changes from an OEM. And so the kernel that actually ships on a device is very custom for that device and very different from upstream version of Linux. And so we've been working to change that for a number of reasons, which I'm not going to get into here, but was the topic of last year's talk. So you can go look at that. We also have public documentation on GKI that you can read. So the big push, and this is a multi-year push, has been to get all of the hardware-specific code out of the generic kernel into vendor modules, and then one of the big parts of this effort is that we have to have a stable interface between those vendor modules and the generic kernel so that they can ship asynchronously. We've also had Plumbers talks on how we're maintaining that stable KMI, so we're not going to go into that today either, but again, you're free to ask questions or look at our public documentation on that. So status-wise, when we talked last year at Plumbers, we were close to shipping what we called GKI 1.0, which was the first iteration of what is going to be several iterations, where we worked with our partners. There was lots more upstreaming activity in the Android community, a lot more patches that would have been on devices that were actually submitted upstream, and if not submitted upstream, submitted to the Android kernel. And the separation, we made a lot of progress on that separation between the hardware specific code and the common code. And last year in Android 11, we shipped this GKI 1.0, which was a compliance test, really, where the kernel that shipped on devices had to implement the KMI interface and then pass tests with the GKI kernel in place for certification. But then the actual devices that shipped, or the actual kernels that shipped on devices, was the device kernel modified by the SoC vendor and the OEMs as before. That was a success, and you can see today, if you have devices with the 5.4 kernel, that is all this GKI 1.0, and it's not running the GKI kernel, but you can, on your device, reflash it with the GKI kernel plus Google's version of the system partition, and that will work. And it's been spot tested in a few cases and does seem to work. This year, with Android 12, which will be shipping within a few months, we're taking that the step further and actually shipping the generic kernel on devices. So again, we've been working very closely with all of those partners to get everything in place so that their products have the features that they need to be competitive in the marketplace, but that we could make the separation and have generic kernel separated from the implementation of the hardware features or some of their value add features. The testing has changed. They don't have to do any special testing for GKI, except that there are tests when they're running for compliance that verify that the kernel that's part of the test is our certified image that was built by Google. So the big difference between the kernels that we're shipping with GKI and upstream is that we rely heavily on out-of-tree modules for the implementations of the vendor code. So it is so there's a set of patches that wouldn't really fly upstream that we accept in order to make that happen. And so sort of running down the classes of those issues, we provide a notion of vendor hooks. So where in the past a vendor or an OEM may have made a change in the core kernel, if that's a feature that is really important for their product this year, we provide what we call a vendor hook that allows them to get control at some key points in the core kernel to implement their value adds. And the way that's implemented is we have two flavors of hooks. One is our regular hooks, which is really nothing more than trace points. And so they instantiated trace point, we have a naming convention that we can easily identify that it's one of these vendor hooks. And then they can attach to the trace point from their vendor module and implement whatever they need to implement at that location. We have a second flavor, which we call restricted hooks. Those differ from trace points in the sense that the code that executes behind the handler is not necessarily in an atomic context. It's in whatever context the hook was in. So it's not just a naked pointer, but you could think of it as that, where whatever context the hook is executing in, it transfers control to the vendor module in that same context. And so that allows, in some cases, sleeps and some other things. And then also, in order to support this, we have a number of exports that we enable that wouldn't normally be allowed upstream, but we need to allow vendors to implement some of this functionality in their vendor modules. And then we have special kconfig options as well for cases where a module, if it were turned on in the build, would also select a number of other configs. We need to select those on behalf of those modules when building the core kernel. This slide just shows what those hooks look like. So in the core kernel, it just looks like a trace point. In the vendor module, they can register for it, and then they have a handler that executes. We prefer this over the code actually being added as out-of-tree code into the Android kernel, because first of all, it lets different vendors and OEMs implement the handlers in different ways. And secondly, of course, what we prefer is no extra code. We want to be as close to upstream as we possibly can. And so we're allowing a lot of these hooks right now. We hope eventually to start working through those and get all that value-added code upstream as well. But this is a multi-year project. We don't expect that we'll ever get all the way there. And going forward, right now we're in this first period here, 2020 to 2022, and what we're really working on hard is getting the whole Android kernel development community to implement what they need to for their products in either via hooks or in some cases patches that go into Android mainline. And so we look at that as we're taking all of the ways that the whole ecosystem differed from upstream Linux and pushing that up into the Android kernel for now in the form of hooks or in the form of out-of-tree patches that go into the Android kernel. There's been a lot of, as I mentioned before, a lot of upstreaming activity. So a lot of that stuff that's always been buried in device kernels has already been upstreamed. We're isolating it to vendor modules. Again, that might mean hooks in the core kernel. Or we're taking some patches into the Android common kernel. We're trying to minimize that. And then as we move on, that all of that technical debt that we're accumulating in the Android common kernel, we're analyzing and working towards eliminating that debt. But right now, we're accumulating it faster than we're eliminating it. And you can see the debt pretty clearly. We keep a quilt series for our Android mainline, which is our branch that tracks the mainline kernel in a quilt series at that link. And so 2023, 2024, we believe that we'll start reducing debt faster than we are accumulating it. And the goal, of course, is to get as aligned with upstream as we possibly can. Though since out-of-tree modules are really important for our use case, we do expect that we'll always have a set of exports and some things that are that are different or in addition to what's upstream. But this whole project is a multi-year project working towards getting rid of as many out-of-tree patches as we possibly can and aligning as much as possible with upstream. So with that, we have probably a minute or two if there's a quick question. Otherwise, we'll defer all questions to the BOF on Friday.
Todd, there's one from Geert, which is, do you support any interrupt controllers or timers than GSI, other than GSI and uptimers modules?
I can
I'm
answer.
not. Yeah, we'll let Servan answer that one.
We do support timers and interrupt as modules. Actually, interrupt controllers as modules as upstream too. We support it in upstream now. The timer stuff, we're working through it to upstream that part.
All right, maybe one more quick question.
Yes, there is one from Brian Masney, which is to help make the kernel more generic, are there plans from the Android project to request ACPI firmware from the hardware vendors?
There aren't plans right now simply because in the ARM64 ecosystem, which we aren't doing x86 right now, all the devices that are part of the GKI are ARM64, and so in our ecosystem there haven't been requests for ACPI. If there were, we would certainly work with it to get there. If we ever did an x86 version, I think we would also we would be looking at that. So currently, answer is no. And with that, I think we better move on to the next talk.
Alrighty, you should have control.
Okay, so I will actually start and then hand over to Wei. So hi everyone, I'm Quentin, and Wei and I are going to talk about some of the work we've been doing on uclamp for Android. So if you can go to the next slide, Wei, please. I guess to start, what we should say is that Android has now switched to using uclamp completely and only uclamp. We have abandoned SCTune, which some of you may know as the out-of-tree Android specific equivalent of uclamp that we used to carry in Android, but that's completely gone now. We've switched to uclamp and we're committed to using uclamp. And as we've switched from SCTune to uclamp, we have tried to really make good use of all of the new features that uclamp is bringing to the table. And by that, I mean that we have also been using things such as the max clamping feature and the per task API. And as we've tested those things, we have found a few cases where those features were not exactly behaving the way we were expecting them to work, and we found a few issues and pain points. So what we would like to do is basically discuss some of those pain points with the community and hopefully find, discuss possible solutions to move forward. So can you go to the next slide, please? Yeah. So just to introduce the first problem, I'd like to walk you through the setup we have for the CPU controller today. The setup is pretty simple. We have one group per role of applications. And so what that means is that basically the application that is currently in focus on the phone of the user will be classified as the top app application. And all of the tasks of that application go into the top app group. All of the apps that are running on the device but that are not currently in focus or interacting with the user go into the background group. The foreground group is dedicated for things that are visible to the user, but the user can't interact with it. The system group is for system threads and so on and so forth. So we have a bunch of groups like this where we classify the tasks. And when a user switches from one application to the other, then we migrate the threads between the groups in order to reflect that change. In terms of uclamp settings, we are using uclamp min for the top app group in order to boost those tasks that are important as per the definition of importance that we have in Android. And we use a uclamp max on the background group in order to not waste power on those tasks. So yeah, that's pretty much the setup that we have. Now, if you are familiar with C groups, you will probably think that this setup is actually not, well, let's say not perfect, because it goes completely against the official recommendation for C groups, which is to classify once and then to tune the parameters. So if we wanted to do that in Android, we would basically need to create one group per application, and then we would tune the parameters of those groups dynamically instead of migrating between groups with static parameters. And we have tried to do that. And in fact, we have been able to move to the correct model for other C group controllers, I believe. But in the specific case of the CPU controller, we have seen a few issues with that. And so specifically what we have seen is that in order to use uclamp min efficiently, uclamp max efficiently on the background group, we also needed to use CPU shares as well. And that has made our setup for the CPU controller a lot more complicated. So with that, I will let Wei take over to explain in more details what exactly we've been doing with CPU shares and why that is a problem for the CPU controller.
Okay, thanks, Quentin, for the introduction. So let me share some of the learnings and the experience we are basically we have been experiencing like in the migrating to the new uclamp feature from the Absolute kernel. So as Quentin just mentioned, right, the first problem I'm going to talk about is the CPU shares versus the unified hierarchy of the C group. Okay, so let me first talk about like the CPU shares usage in Android. So per our experiment and study, CPU shares actually can help, for example, like sometimes 5% to even half of the latency reduction for app launch use case under, for example, some heavy background workload, for example, Dex280. This is a compiler program that updating your app or doing the background OTA. The CPU shares, actually the feature helps guarantee the top app and other, like non-background work can get a decent amount of like CPU time. So regardless of like those background execution. So that's the main usage of like the CPU shares. However, like the CPU shares, we only want to pull those to background group. Like two reasons mainly, right? So the first is like I think like let me switch the very first. This is the C group V1 hierarchy that we're currently using in Android, right? So the problem of like setting the CPU shares on this hierarchy is that we only want to share, set the CPU shares on the background group. However, there's a multiple other group parallel to CPU shares, right? The system is mainly the root group. We don't have anything in the root. So the foreground group is, as Quentin mentioned, some foreground or user-facing services, important system server services, and top app apparently is the one that currently rendering the script. So we want to share, set the CPU shares on the background, but like that will also introduce, because those are parallel group, introduce a fairness between those groups. If like they are migrating to C group V2, the problem become more inevitable because like as just mentioned, but about like those parallel group, the fairness between them. And also another reason mentioned here is the number of like the group, the apps is also non-static. So it's hard to scale a fixed bandwidth as a presetting. So if we do like the V2 migration, we have to adjust the shares dynamically, which is possible, but roughly like complicated for the user space. The second, the last one is also related to the C group hierarchy. So CPU shares and uclam currently share the same controller. I will switch back to the graph. So as Quintin just mentioned, right, we have several settings among those different groups for min and max setting. But also we want to only set the CPU shares on background group. So this is actually limiting the usage of the uclam and CPU shares together. Okay, so the next problem is slightly related to the first one. So it's about the uclam max aggregation. So currently, like the uclam max aggregation follows the rule listed here. So the rank level, the utilization is sum of all the tasks, and uclam max is actually the max of those, right? The problem we see is that, so for example, long-running background work that with some uclam setting, for example, here this is a 50. And there could be a very short of non-restricted top-up work co-scheduled on the same CPU. So if that happens, then the run queue level of like the uclam max is released. And then the CPU is just to go to the max. Even though the utilization of the top-up task is quite small. It's basically a very small task. So we don't need like that boost. But due to this implementation, we have to go to Fmax for no reason. Another problem is that right now we have like a single uclam max value that map to that, for example, the 50 value here can actually map to a very inefficient CPU on some cluster, for example, little cluster. Maybe and model-based frequency selection could really help for this kind of issue. On the proposal side, or as a product workaround, is that we're considering using the uclam max at the CFS run queue level. So the contribution of the entire CFS subtree will be restricted by the uclam setting. So we have like the CPU, the uclam max setting per group, right? And the per group uclam max will be the entire subtree's run queue or CFS run queue's contribution to the CPU level of run queue. The next one is also related to the last problem, is that we also want to let the CPU run at the efficiency point for each power domain given the uclam max setting. So those are the...
Whenever you get the chance, if you can sort of switch to discussion, it'd be great, because we have about 8 minutes left, and we want to try to have as much discussion as possible. Whenever you get the chance, if you could switch to that, it'd be great.
Okay.
I think
okay.
Maybe we can stick with the previous slide with the proposal and see if anybody has some thoughts about that, about the idea of clamping at the CFS run queue level instead of clamping only at the run queue level, at the root CFS run queue level. I'm just curious to see if anybody in the audience has like objections against that, or ideas to implement that differently, or issues.
Yeah, so I think what you what you use here is that your specific setup of task groups, right? That you have those foreground, background, top up thing as first level C groups. And then you per seed, you decide, should I use the clamp value of this container as a task group, or should I use the real util average of the CFS run queue attached to this task group? And you sum those 4 groups up, which lets you also consider the tasks which are running in the root CFS run queue. And those guys you probably don't clamp. And then you sum up all of this, and this is then the value you use for determining the overall system utilization. And this is what you clamp only per first level task group.
Yeah, I guess the idea is really to prevent unimportant tasks from contributing to more than the uclamp max level stuff.
And those unimportant tasks, they are essentially in the root CFS run queue, right?
Not necessarily. I mean, they can.
Okay.
If we have tasks in a group, or even it doesn't have to be at the CFS run queue level actually. But if we have tasks that have a uclamp max set through some way, we want to make sure that they cannot contribute to the run queue level request to something higher than what they have been limited. The problem that Wei has described in the previous slide is basically that we have a background task that is running for a very, very long time because it is clamped. The utilization of that task goes up really high. And then when we have like a top-up task that doesn't have uclamp max that is co-scheduled in that country, all of a sudden the utilization of that unimportant background task becomes visible.
True. No, I think the problem is understood.
Yeah. And so I think that what the suggestion with the CFS run queue stuff is to make sure that that unimportant background task can never explode the run queue level request by clumping earlier in the stack somehow.
But I think this problem can also be solved differently, right? When we are on mainline now in max aggregation, we just don't consider those we find a way to not consider those other tasks to ruin the max aggregation, which is essentially happening right now. So we don't have to do these kind of iterating over all the CFS run queues if there would be a way to do this. Just like the example you gave, like the small task which comes in, which is not uclamp max.
Mm-hmm.
Find a way to avoid that this task ruins the clamping scenario you just have for the long-running background task.
You mean by not placing it on?
By not considering it for clamping.
By not considering it for clamping.
I'm not saying there is a solution already, but like your solution you have is working perfectly fine for you. But like I said, it's very much limited or supported by your CFS run queue or by your task group setup in Android. It's limited, right? You have control over it, and you also probably don't use the per task interface. You just rely on uclamp max interface per CFS per task group. Right? All the tasks you put into a task group, they essentially have to obey to the uclamp max value of the task group. You don't use this second level thing where the task can have its own task group, its own uclamp max value.
Yeah, it's
we got 3 minutes left.
Okay. Martin, was that something you wanted to talk about?
We've actually been discussing this problem a little bit in our team, and the problem you described, where you have something that turns up and sort of lifts the cap, and you're not interested in doing so. I can see that problem, but you can't really ignore all tasks. You need to find a way to exclude some tasks from your criteria for lifting the uclamp max, and I think there are ways to do it. The problem here is if you're not careful, you might break the or you might reduce the performance of tasks that are not clamped. It's a very deep discussion to discuss how you can max breaks various things in the scheduler, because you suddenly have some utilization that's actually using a lot of CPU time, but at the same time you sort of close your eyes and say, no, this is clamped, so it doesn't actually count more than this, but in reality it counts this much. And that breaks a lot of things, but I think there is a clever way that you can get around the problem. So I think we should try to have a deep dive on it, perhaps in a different setting.
Okay, that sounds good. I think we should take that offline. I think we're running out of time, but
Yep.
that sounds good. We should take it offline.
Sure.
Okay, thank you guys very much.
Thank you.
Yeah, we still have 2 minutes if you want to continue, but we're going to be switching, of course, to the next presentation. And I encourage you to sort of come back and discuss this at the BOF later on Friday. If you want to continue this conversation, you're more than welcome to join and further discuss it there. So we're just going to wait. Yeah, your audio might be off here. We're just going to wait for just a proper mark there, and we'll start. And just make sure your audio is on. I think you're on Just Listen. The sort of icon on the. There you go. You might have got your mic properly working. Test it now. So Paul's audio is good. Alessio, do you want to test your audio?
Okay, let's see. I hope it works.
Yeah, I can hear you now. Okay, floor is yours.
Okay, so hello everyone. My name is Alessio Balsini. I'm going to introduce you to this presentation together with Paul Lawrence. So we will be presenting how we are using Fuse in Android, the performance bottlenecks we identified, and we would also be talking about a couple of mitigations that we are currently working on. So in Android, we are using Fuse for a bunch of different reasons. So basically what it happens is that an application, when it tries to accept some shared data, it uses a Fuse mount point that with the Fuse driver, it would be getting all the file system operations, and the Fuse driver would be forwarding all these operations to a Fuse daemon through the /dev/Fuse file. The Fuse daemon would basically implement all the logic behind these file system operations. It can be either single-threaded or multi-threaded. And as long as in our case, the Fuse daemon is basically implemented a stacked pass-through file system, all these operations would be almost kind of happening to a lower file system that is implemented as either F2FS, ext4, or others. And why we are using Fuse. So there's a bunch of reasons why the Fuse architecture is very helpful for us. First of all, because updating a Fuse daemon is much, much easier than updating the kernel. And we would be also able to have some extra permission checks. So for instance, we can be more fine-grained in checking if an application can access some folders or some specific files. We can also implement data redaction. So at runtime, we can change the contents of a return file. So for example, in our specific case, if a picture has some information in their metadata, for instance, GPS location, but the application trying to access this file doesn't have this permission, we can zero this metadata. We can also implement things like live transcoding. So maybe the file that is a media file that is encoded in the storage with a very optimized and new encoding, we can return a different encoded file that can be read by applications that are legacy and are not implementing that specific coded. We can also simplify some behaviors, like in a smartphone, we might plug or unplug some SD cards or anything, and this can be much easier to handle with a stacked file system like this. The problem is that with this complex architecture, we have some additional fuse daemon logic, but this is something that we want because this is part of our feature, or the fuse daemon feature. Unfortunately, we also have a few extra VFS traversals. So we are accessing two different file systems, and we like the fact that we have some extra like permission checkings at every entry point. But in the case, we are doing exactly a pass-through stacking file system, and we are returning exactly, for instance, the same file we have in the backing file system. Then we would be caching the same pages twice for both the fuse file system and the lower file system. Plus, in this long pipeline of events, we would be passing a bunch of data that is mostly pointers. Plus, Fuse also implements splicing and read ahead that are helping with these. But the problem is that with writes and random read or write operations, this is still an issue and is a spot where that we can improve. Plus, the long pipeline also introduces some communication delays and context switches for the fuse daemon and the applications that are executing concurrently. And we also have a bunch of user to kernel and vice versa switches. The fuse daemon can be multi-programmed, but again, if we want to do that, we need to have some extra lockings that still prevent some scaling. And these whole issues are happening at almost every fuse file system operation. So the first solution we were proposing is fuse pass-through. And I take the chance of thanking everybody in the community who either contributed or gave really helpful feedback. And thanks to your help, now we are shipping this out of tree change in Android 12. So what is this? Basically, the idea is that whenever we are opening a file, the fuse daemon already knows if any extra like fuse daemon logic needs to be applied to the consecutive read or write or memory mapped operations. So if we know that no extra logic is required, then why do that? So at open time, the fuse daemon can execute an ioctl that is part of the fuse pass-through feature that basically just tells, hey, we can do everything that is coming next, especially for the read, write, and memory mapped operations directly to the lower file system. And this is what happens in the fuse driver. So if we see that we have a file pointer into the newly added fuse file data structure within fuse, then we would be just forwarding the same read, write, or memory mapped operation to the lower file system. We would be also using the fuse daemon credentials to keep the same security access paradigm as fuse. But this would happen until we would be closing the fuse file. So there's no way yet to block the bridge between the fuse file to the lower file system. And as we can see from this picture, we would be just having a direct bridge between the application, fuse driver, and lower file system without any extra effort from the fuse daemon. And we can see the advantages by looking at these benchmarks, where for write, random read, and random write operations, we are very, very close to the native performance. We are also very close to the sequential read operations, but also fuse, as it was before this change, was actually great. But this is basically the result of the great read ahead caching mechanism. So thanks to the feedback, we have still some issues with fuse pass-through, so we cannot close it. But with all these benefits, as I mentioned, we're using fuse pass-through in Android, and we would like to extend this with extra features, especially with some very flexible BPF features that Paul is going to talk about.
Okay, next. How do I move slides? Next.
I do. I can change your slides.
Yes. Thank you. So yes, so having done pass-through, and remembering back to a presentation XViews a couple of 3 years, it doesn't matter how many years ago, that was given at LPC, and based also on the fact that I've been working on a stacking file system for the last couple of years. It struck me that you could easily put these three concepts together. Not easily. You can put these three concepts together to produce fuse, a stacking fuse with BPF to control what gets passed down and how it gets passed down. So the idea is that BPF would be a sort of pre-filter on all requests that could then get passed to the lower file system. And you could also pass them, you could pre-filter in user space. Of course, that reduces the advantage, but then if you only need that some of the time, that would give you most of the advantage you need. So the reason for doing this, as Alessio says, is that Android wants to use Fuse. We've tried to use Fuse in multiple projects over the years. I counted 5 when I was thinking about this, times we've tried to use Fuse. And all but one of those has been pulled eventually because of the performance issues. And even the one we've shipped, we would like to improve the performance. So Fuse is really something Android wants to use, but we just can't. And whenever we want to use it, we always want to use it in a stacking file system mode, where we simply want to change some fairly small aspects of what's being read. So making Fuse into a stacking file system natively, and keeping most of the requests in the kernel using BPF just seems like a very natural thing to do to solve this problem. That's what we're attempting to do. It's very much in the preliminary stages. The soon on LKML is, well, depends how you define soon, I guess. It's a little optimistic, but hopefully we'll get something out this year or early next year. I don't plan to go through the detailed architecture, especially as I'm almost out of time. But let's have the next slide. What I've been experimenting with is simply adding a backing inode to an inode and a filter to each inode. Will have a backing inode and a BPF optionally. The existence of the backing inode means you are in this pass-through BPF mode. The BPF is called in such situations on all operations, passing in essentially the fuse args parameter for those who know fuse, so the BPF gets a chance to look at the arguments that Fuse would present to user space, and theoretically modify them, and also pass them to user space as required. These will then the call will happen to the backing file system. If that is what is wanted, there's an option to switch back to classic Fuse at that point, what I call classic Fuse. And after the backing file system operation has happened, the BPF could again inspect the results and make a further decision to pass back down to user space. So, for example, in the case of redaction, this means we can just let the read happen, and then use a BPF map to decide whether that read happened from an area of the file that needs to be redacted, and only in that situation would the read get passed down to the Fuse daemon. So you only get the performance hit exactly when you need it. So that's, I think, this is, yes.
If you want to switch to discussion whenever you get the chance, and whenever you're going to segue
yes.
there.
This is actually, well, this is the last slide, I believe. So Fuse, just a quick summary. Fuse passes through an entire file. When it has been determined by Fuse that file is simply going to be the backing file. Fuse BPF is an experimental attempt to make this far more granular and use BPF. Oh, by the way, with the Fuse BPF, we're using BPF for everything, file operations and directory operations. So that makes a huge difference. And one of the problems we have with Fuse pass-through, well, the biggest problem is obvious. The directory operations still go to user space. So we still get a big hit, especially when you have a large collection of small files, which is not uncommon in Android and every other situation. So, questions? Comments? Silence. What changes me to fuse? The main change is that I've written a macro that implements this entire flow, an inline function, and that has to be inserted just before at the right point in each operation. So there's 40 odd fuse operations. We need to add this macro to each of those. It's fairly non-intrusive. That was one of my goals, was to not actually change fuse much. So that if you're not using this, if you don't want to use this, there will be no impact on the main flow. All it will actually do is check to see if there's a backing inode. And if there isn't one, it will just carry on with the old path. I mean, of course, that's not quite true. There's one or two cleanup operations as well added. But the main change is that.
Hi.
Hi.
Hey, you mentioned the directory operations, and I might have asked this before on mail, but it's good to repeat it here. So one way is to go to BPF, right? And one is to continue the fuse pass-through direction and go to directories and pass through directory operation. Is this something that you guys are right now considering?
So just to be clear, passing through directories really means you're throwing your hands in the air and giving up at that point, which actually is really useful in some situations. Don't get me wrong.
Why?
Because I mean, essentially at that point, fuse becomes a bind mount. I mean, once you pass through directories, you have no chance. Everything will simply be the underlying file system at that point. Or am I missing something? So fuse BPF gives us a pass through on directories, but it also maintains control, so you can still change the operations as you want to. Let me rephrase that. This is exactly fuse pass through on directories, but by adding BPF, we bring back in a level of control. Am I making sense? I don't know that I am. Alessio, am I making sense?
I think Amir's just posted on chat that he was cut out.
Oh, okay, good. Not good, but good that it wasn't clear. Yeah, so the pass-through on directories, and I mean, certainly in a naive implementation, would simply pass through all directory and all file operations, which is handy once you've decided that this folder is no longer, you simply want to essentially bind mount this part of this tree. But by having BPF, by having the option of, and it's an option, you don't have to have the BPF. By having an option of BPF, you can maintain control. Did that make sense? Yes, that made sense. Yes, Sandy, well put. Any other questions or any follow-up on that question?
So I have a question for the audience. So do you actually believe that, so to me, it sounds like natural to have BPF lined together with fuse as long as these are both mechanisms to let the user space easily interact with the kernel space. So, but do you believe that this solution would be accepted upstream? So for sure it would be hard to do that before posting that on LKML, but this is still work in progress and we are progressing one file system operation after the other, and until we have almost all of them implemented, and it would be hard to have an MVP ready to be shared. But do you believe this is kind of something that would interest the community? And this is an extension to fuse pass-through as it was, that would be just addressing single file pass-through. So in that case, the last concern was that we cannot have fuse pass-through close. And I also tried to implement that by using an extra mapping container, but as also suggested by Miklos. But the problem in that case is that taking as a reference Fuse 2, then it's using IDR and a bunch of other things that where the in our Fuse pass-through case, it's much more racy. So we would be needing so much extra locking that we would be losing all the performance benefits. So any feedback on what I just said?
And I guess the higher level question is, I mean, Alessio is right. What we're doing currently is we're implementing this, we're adding all the file system operations and more and more complete implementation. We would love to know if we're going in the wrong direction. So at what point should we publish and to where is our question? The Xfuse work seems to not be being maintained as far as I can tell. Just to
1 minute, and as a general reminder, you're welcome to sort of take this up back at the BOF on Friday and continue discussion. You know, one of the questions that was there from Sandeep, and I think it echoes some of the questions Paul and Alessio were mentioning, which is, you know, are there sort of precedents for this? Are there any rules, examples, or anything of that sort? So I would sort of encourage people to think about that and possibly come back on Friday and discuss this some more. Fascinating topic for sure.
Okay, thank you.
Thank you, guys.
All right, David, you've got control. You'll also need to switch your audio to enable your mic.
So I'm going to present. So do I have the presenter right?
I'll give that to you in just a second here.
Sure.
All right, you should have control now.
All right. I'm not sure if video is working.
Not seeing any video at this point.
Let me see. Okay. Right. I'm Akhilesh from the Android kernel team. I'm going to talk about the snapshots in user space. Quick recap about virtual AV. Android 11 introduced the concept of virtual AV for OTA updates. The virtual AV brings in the cool features of seamless updates, rollback, and most importantly, you don't need additional space for dynamic partitions. Whenever the OTA is being applied, we allocate space dynamically on the data partition, and once the OTA is completed, the reclaimed space is given back to the user. So that's virtual AV as compared to the traditional AV updates. So how do we implement virtual AV? So we use DM snapshot in the kernel to implement virtual AV, wherein we have the DM linear system base, which is the device which is being snapshotted, and then we have the DM linear cow device, which is the kernel cow format. So on top of that, we create the DM snapshot, then /system, which is the root partitions, is mounted off DM Verity. It sits on top of DM snapshot. So so once the snapshot target is moved to the merge, we merge all the cow format delta changes to the DM linear system base. So that's how we implement virtual AV here. So that's Android 11. Now, with reliance on DM snapshot, one of the one of the problems we see is that there is no compression by using the kernel curve format, meaning every single block is a replace operation. Now, which means that the entire OTA package is uncompressed, but when you're using the ATM snapshot in the kernel, you have to uncompress all the OTA packages, and then if the OTA package has move operations, let's say move block X to block Y, each of these move or copy operations is inherently converted to a replace operation, which ends up eating additional space in the /data partition. Now, that's the problem we have with using DM snapshots and with using kernel curve format. Now, to address this, Android 12 introduced the concept of compressed snapshots, wherein we have our own Android curve format, which introduces additional operations, wherein we have zero ops. Then we also have replace ops, wherein the block is replaced, but we do compress using GC compression. And then we also have additional copy operations, wherein we say move block X to block Y. And then the fourth, the recent introduced operation XOR, wherein the destination block is just an XOR of the pre-existing block, and then with the change content in the curve file. With these four operations, we can have better compression ratio as compared to the traditional kernel curve format changes. So how do we implement? So Android 12 introduced the compression. We still continue to use DM snapshot, but the only difference now is that we don't use the kernel curve format. Now we use DM user, which is a kernel module, something like Fuse for block devices. Now the IO from DM snapshot goes to the DM user, which gets routed to the snap user daemon in the user space. The daemon is now responsible for translating all the IO requests from DM snapshot, and then the translated IO request is communicated back to the Android curve format. Now this is Android 12. So this brings in cool features of compression. But there are challenges with this. So some of the performance numbers for compression is it's cool that for the incremental ODA, we see that the compression ratio is about 8x, wherein it gets reduced from 4 gig to about 500 MB. So all said and done, we see some few challenges, primarily with the snapshot merge time. We have seen instances wherein this merge time increases. There are use cases wherein merge time is about 10 to 15 minutes. Even though the merge happens in the background, users are not impacted, but then still 10 to 15 minutes is a huge time. And the second problem we see is the complexity of the daemon. The snap user daemon, which is handling all the IO requests from the DM snapshot, is inherently very complex. And the third problems we see is the boot time. Since the system partition is mounted off DM snapshot, which is internally mounted on top of DM user, every single IO request it has to be handled by the daemon. So there is constant switching between user space and the kernel. So all these are some of the bottlenecks we see with introducing the compressed snapshots. So to address this, what we're trying to do now is we are trying to merge the entire snapshot merge to the user space completely. With this, the daemon is completely in control of handling end-to-end merging. And there is no DM snapshots now. We are no longer going to use DM snapshot in the kernel. System partition will directly be mounted of DM user, and then every single IO request will be moved to the daemon. Essentially, what this means is some of these snapshots handling will be done by the daemon itself right now. Now, this gives us flexibility, wherein we no longer have constant context switches between user space and the kernel during merge. So we have been experimenting this with the prototype, and we see some at least increments in the merge time for about 50%. But still, yeah, this is the last slide. But still, we still have the system partition mounted at VM user, which means that all the IO requests from the root partition will still be routed to the daemon. So we still have challenge of improving the boot time regressions. So that's where we are trying to see how efficiently we can optimize some of the DM user increments. So we're trying to see how we could use IOUing and integrate it with the Snap user daemon, wherein we can cut off some of the system call overheads. So that's one area we are looking at. One of the other primary reasons why we still stick to DM user, and because Device Mapper gives us the flexibility to switch DM tables under the hood once the IAM merge is completed. And secondly, during boot up process, we have a scenario wherein the Snap user daemon have to be paused and switched because we have to enable SE policy. What this essentially means is that we need some kind of a solution in the kernel wherein the IOs can be queued before which the daemon can completely take over. Now, Device Mapper gives us that flexibility wherein when we suspend, we can suspend the IOs and then resume back the IOs. So those are the two key features of Device Mapper, and that's one of the primary reasons why we are still sticking to DM user here. But as you notice, DM user is still out of tree. We are hoping for a solution to see how close we can be using the upstream features. One of the primary evaluation is feedback we received was why not use NBD, network block device. We have to evaluate that now that there is no merge dependency on DM user. So we want to see how NBD uses, but as I said, I'm not sure if NBD allows us, NBD uses the flexibility of queuing the IOs in the kernel. That is something which needs to be evaluated. Yeah, and that's pretty much it. I'm open the floor for any questions if you have. Yeah, so I'm just curious if you guys have any other suggestion apart from DM user, that will be really great. I mean, we'll be happy to evaluate that. Yeah, NBD, what happened with NBD? Yes, NBD, network block device, we need to evaluate the overhead of network block device on the boot time. That is something which needs to be done. But as I said, we are not sure if NVD gives us the flexibility of queuing the IOs when we are switching the daemon in the user space. Because if that is the case, we'll have to go and extend NVD features as well.
Yeah, so I think we talked about this some on the upstream.
Right.
Yeah, and I like in theory we can pass the handle from the one NBD instance to the other to deal with the SE policy stuff, but that's a little bit on the fragile side because it requires orchestrating all these things in the right way. Not, yeah, I guess we talked about this. Yeah. So anyway.
Yeah. Yeah. Okay, is TM user going to get upstream or recent? So first we need to evaluate other solutions out there, such as Mtd, to get at least some baseline performance. Then we can check with the device mapper maintainers to see if this is something which they'll be interested on, to see how efficient VM user is and what is some of the use cases. I mean, this is one of the use cases why we need VM user. Once we have the baseline performance numbers, we should be able to upstream. Yes. Also, there are other interests from a couple of other teams in Google about log device and user space, and even they are working on upstreaming it. So probably we'll have to sync with them to see what are their use cases before which we can synchronize and see if VM user can be used for their use case as well. I'll be excited. Sure. Yeah. As I said, certainly. Once we have the baseline numbers, because the last time I remember VM user was sent upstream, I think the discussion was cut off, and we wanted to have the performance evaluation done. That is where I think we want to take it further. So that's the only thing. Have you considered implementing more efficient curve format for DM snapshot? So when you say DM snapshot, for the DM snapshot in the kernel, right? So yes, so when compressed snapshots was being designed, one of the things, so the current Android curve format is extremely specific to Android ecosystem. In theory, yes, we could move everything to the kernel and extend DM snapshot in the kernel itself. We could do that, but we didn't go that route because the curve format is too specific to the Android, and having it in user space, we get more control to implement merging as well as the write operations. But if there are interests, then yes, in theory, yes, we could move to the kernel as well.
Yeah, so I think like early in the project, we'd actually considered doing like the cow format directly in the kernel.
Right.
But the Android OTAs are like very optimized, and we wanted to make sure not to introduce a bunch of dependencies between the kernel and the OTA folks and all that sort of stuff. So doing it in a user space gives us the flexibility to, like keep that cow snapshot format somewhat flexible, because we only need to keep it between boots, right? It's not like a permanent snapshot thing. So it lets us move it around a little bit more.
Right. Yeah, I mean, yeah. Yeah, as David is mentioning, when it's doing like adding new kernel features over OTA in the kernel itself. So, and having it in user space. Yeah, having it in user space, the other thing is we have complete control, wherein we also have requests from few vendors to have merge verification when the snapshot merge is being done. Those are the things which we have more control if we have it in user space.
Yeah, David also pointed out letting our user space team contribute more directly to the snapshot OTA code. Which is a big driver, because there's a lot of folks there, and getting something like this, which is very application logic-y, out of the kernel is nice because it lets kind of more people work on it. So that's always a benefit. the DM is nice, but doing it, it's still a little bit hairy after doing the DM user stuff, and it's certainly a lot easier to do this in user space. There's a lot of nice.
I mean, now that the merge is moved to the user space, the dependency on DM user is very minimal because the only IOs which go through DM user is from the root partition, and that too, it's only visible until the merge is completed. So, so the only optimization we need to focus on is improving the boot time performance. That's the only IOs which is served from DM user. But
to your point, if we had our own kernel snapshot, we kind of looked into doing one of the snapshot formats, and there would be enough hooks in there that we'd sort of have code sitting around the whole time after boot on that first boot when you spin up, and it's nice to be able to just completely get rid of that. It makes things a lot safer feeling if you can bound the amount of time you're actually running.
Exactly, right.
We have 1 minute and we go for break afterwards.
Yeah, sorry, David pointed out in the chat, we considered doing DM, like doing a DM snap user to take the snapshot exception store and put it in user space. I guess we're on break, so sorry, I was on a chat.
No, that's fine. It's good. Thank you for this. So we are sort of officially on break here until 8:35 a.m. Pacific or 3:35 p.m. UTC. And then when we come back, we'll look at the thermal core usage challenges in Android. All right. Thank you, everyone. See you in a short bit. Okay, we'll be back in session in a minute or two here. Probably want to switch to the upcoming slides for thermal. Perfect, thank you. Okay, Wei, if you want to put your webcam on and get ready to start within a minute here. Thank you. Go ahead whenever you want, Wei.
Okay, thanks. So, hello everyone. My name is Wei Wang. I'm from Android Pixel Performance and Thermal team. So today I'm going to talk about thermal core usage challenges in Android. Basically, like talk about some of the production usage of thermal core, which is a framework provided by upstream kernel. So basically, this talk is about the production use of the thermal core framework and issues around using it, some pain points maybe, and some source and possible solution to resolve like those pain points. Okay, so like the Android, the whole ecosystem has been using thermal core infrastructure for both junction temperature and T-skin mitigation, and for many years. We have been seeing many thermal DFFS features built around thermal core by many OEM vendors. So this is really a core infrastructure the Android ecosystem used for thermal solution. So here's above like 1,000 feet above ground view of the thermal core framework. So it basically has three main components. The thermal zone is for reporting temperature, and the coolant device is for limiting the power. And something in the middle is the thermal governor, which is for control algorithm. For example, we have a IPA contributed by ARM, we have a stepwise, and we have some user space governor. On the thermal zone side, there's a couple of types of like different sensors. For example, the junction temperature sensor is used for making sure the chip is running within the spec. It's not burning up like the chip or melting down the board. So the T-skin sensor is usually like we call this enclosure sensor or ball sensor. It's actually placed very near the enclosure to make sure the user using the device is not being burned. So in the middle is some other type of sensor that's also kind of like a virtual sensor or whatever that's using the core thermal or thermal core framework. For example, the BCL we call the battery current limiting. It's some sort of like a virtual sensor that makes sure the board or the device is not burned out. And on the coolant device side, usually we have CPU DFFS control, we have GPU DFFS control, and we have TPU or whatever the accelerator on the system or on the SoC that can be also doing DFFS kind of like a scaling work. And also we have like some other hardware, flashlight, modem, or even display, those high power draining devices or components. Okay, so here I'm going to talk about some problem about like using the Summon Core. So I think I updated the slides. Anyway, I can use this. So the first problem, let me actually talk about this, is the aggregation of the kernel device votes, or basically we call it the interaction between user space governor and other governors. So the sysfs interface for user space governor usually is called the current state under the kernel device. So many thermal daemons we see like in the user space actually is using that for limiting the power. And also the user space governor or user or thermal daemon or whatever like the OEM call those solution, they will also pulling or get notified with the thermal zone particularly. But same cooling device can be also used by multiple thermal zone, right? For example, on the junction temperature, it can control the CPU. And T-skin side, which could be used by user space daemon, usually, because it's a slow changing and there's some more complicated rule there. It can also control the CPU power. Similarly, on the BCL side, right? So everything can control the same cooling device. Thanks to the aggregation happens in the framework, like Summon Core framework level. So all the internal thermal zones will have a very good aggregation. For example, junction temperature, BCL, if they are using internal thermal zone, the aggregation automatically happen. But if like there's a user space governor running somewhere, and it's vote through the current cooling state, that will be the vote will override whatever the internal thermal zone vote, and basically like the both ways, right? Because there's no aggregation method there. So the proposal is quite simple: is to add another level like aggregation for the user space governor to aggregate like the votes between the user space governor and also other internal governors. Another problem is also related to the.
Wait, can I interrupt you? Could you just go back to the previous slide? Maybe sort of, and this is a suggestion. It's your presentation, but may I suggest that you might want to open it for discussion for the proposal here before moving on to the next problem? Does that make sense to you, or whatever you want? Just to sort of suggesting that this might be a good discussion point if that works for you.
Sure. I'm open. So there's actually like multiple things like in the slides. Like last UCLAM, we didn't really finish all the discussion, but yeah, I think like it's good to have like the open discussion. Let me actually jump into the proposal. So I see actually Daniel is here, or someone that has a better proposal or want to have like a discussion about this.
Yes, Daniel speaking. So we had already this discussion about the several times with different people about this user space governor and aggregating the votes. So the problem is I think the using the cooling device to limit the power is an abuse of the Thermal framework. And actually, we have the user space, and if I understood correctly, the first thing is the user space governors to get notification from the kernel space to have information about the temperature and getting information when the timer zone cross a trip point. And for this reason, we have for the same sensor, we have one it's not what we have upstream, but what we find usually in some changes for the timer framework, we have several timer zones bound to different governors for the same sensor, just for the sake of getting notification and acting on the power on the other side. So that is the reason why we provided the netlink notifications, in order to get rid of the user space governor for these notifications. And on the other side, because we don't want to aggregate between user space and in-kernel governor, we provided a new framework called DTPM, which is based on a power cap framework. And this framework it speaks by itself. It allows to cap the power of a device. So yeah, so we have power numbers here, but we also can use some whatever the power numbers we want to put there. Just a question of consistency. So yeah, the idea is to prevent this disaggregation between user space, and let that do that from the kernel between the framework via the dev PM QS vote we already have.
Yeah, thanks. I think I heard about what you mentioned, some of the solution, basically using the same sensor, both for internal and also user space. Yes, I also seen some of those, but here, let me actually jump back. So here, the problem we are talking about is actually not just for reusing the same sensor. So the basically the multiple thermal zone, they are using different sensor, but they are using that for different purpose. For example, the junction temperature is really moving fast, which is T-skin. On the other hand, the T-skin is slightly slower than that, which is monitoring the board semester. Both can board the same kernel device interface. But I also heard the new framework you're just talking about, which may be targeting for this aggregation problem, right? Okay, so let me jump about the thermal link netlink configuration. So as just discussed, there's some thermal link feature that built upon new upstream support for making the thermal daemon in the user space get more information or precise information from the thermal zone, which is basically getting the input of the temperature. So on that side, we also have some protection pain points of that. So right now, all the thermal zone can generate messages, and we have some kinds of different types of messages, but those are quite spammy. Mostly the user space thermal daemon is interested in those slowly changing signals. For example, T-skin. The junction temperature moves really fast, which is basically the temperature can jump multiple tens of Celsius degree within a couple of milliseconds in high demand workload, right? But T-skin is really multi-seconds moving, slowly moving. So that makes sense for the user space as a daemon to monitor that. So, but all the information generated to the user space is quite overwhelming, because there always been multiple thermal zone in terms of the junction temperature and T-skin and other BCL thermal zone. Think about the next slide is a proposal to filter all configuration on the messages. So that's what we put as a product workaround in some product. We have to do this. But I want to hear maybe there's some better ways about doing the filter of the netlink information.
So a question. So you're proposing that you will add some filtering to the netlink requests that you're proposing? Like
on the thermal zone, basically. Some thermal zone, we can completely mute it because that's irrelevant to user space. So user space, when they set up, it can particularly just monitor specific thermal zone or specific type of message even.
So I think the current netlink allows you to get notification when you cross a passive trip point, right?
Yes, but some of the zone, like they may like happen that happens too often. For example, the junction temperature. So you get like tens of like those information from the user space and wake up like basically those messages are not even interested in the user space level because on the junction temperature. It's usually moving too fast for user space as a solution to make any adjustment.
Yeah, there will be always an issue when two different agents are trying to control the same device, right?
Yes, like that's why, right? Like on the Android side or whatever, right? Like as I mentioned, right? The junction temperature usually like is either in the firmware level or in the kernel level. I seldom see anything like on the user space due to the reason of its fast changing sensor. So yeah, could be there is some solution that build around user space and can also monitor like the junction temperature.
Yeah, like for at least for Intel devices, we, like particularly like T-Skin, which has very, lot of hysteresis. We don't even have any thermal, we don't put any thermal zone inside for those sensors because and we disable it even if it is there, right? So your issue is you want to cool the same device with one with a fast, one which is fast reactive and one with the slow reactive mode, right?
Yeah, we have actually more than some devices. They have like even 20 different thermal zones for various things, right? For example, modem for like there's a really a lot of like thermal sensors, and user space usually just interested like in one of those or maybe two or several, but not entirely the every thermal zone. But some of the thermal zone they move so fast, and basically the user space has to be waken up like due to the current fine.
So you want to
Daniel? Looks like Daniel has been trying to say something. Maybe you want to give him a chance to talk.
Yeah, just I wanted to understand what kind of notification you need.
I think like we should filter on the types of like the information. For example, I think we are running out of time.
You got 3 minutes. Go ahead.
Okay, sure. Thank you. So basically, like I don't think like filter on the type of the information for the sensor is reasonable. Like maybe we should just keep all the things. Usually is the type of the sensor is basically the most factor that affecting how spammy it is. For example, on the faster sensor or slow sensor, which could be junction temperature or could be skin sensor by nature.
Okay, I understand. Thank you.
All right, thank you. So I'm not sure we can cover all the things. The next topic is about the loadable module on the governor side. So since like thermal governor is part of the GKI, and there's no module support for governor or in the one image, it will result like a larger code. But that's what it is. On the other hand, usually in the product, things are not perfect. So there's always been complex rules about the different threshold, even combination of multiple governors. Sometimes I see that used in some product. And also there could be product workaround. So I also see some of the product workaround is implementing like the thermal governor inside a thermal sensor driver, which is involving very complex log usage on the thermal zone side, coolant device side, and also the driver itself, and also separately the trip setting. I think like essentially that's wrong usage. It's probably better to be make like the governor loadable. The last one is virtual sensor support. There's good usage on the virtual sensor of fusion fused sensor in the user space and also in the kernel. So it would be good to have like that support. I think like that's.
We're gonna have to switch, but you're welcome to pick this up back on Friday and continue the conversation then.
Sure. Yeah.
Thank you very much.
All right. That's all like for the slides. Thank you.
Alrighty, Harijin.
Hi everyone, my name is Hridya Valsaraju. I work in the Android kernel team, and today I'm here to talk to you about a new DMA buff memory accounting feature that we have been looking into for Android. In the next few slides, I would like to walk you through the various solutions we explored. And at the end of the presentation, it would be great to hear your thoughts and have a discussion on how we can best implement the feature in an upstream friendly manner. So the problem that we are trying to solve is that currently we do not have a way to limit the total amount of DMA buff memory that is allocated on the behalf of a process. This means that a faulty process is free to continue allocating DMA buff memory until the device falls under memory pressure. So to solve the problem, we would like a way to implement allocator attribution for DMA buffs in Android so that we can set an upper limit for how much DMA buff memory can be allocated on behalf of a process. So the first solution we explored was the memory controller, was the MEMCG group controller. However, with the per process C group hierarchy that Android is currently using, when we enabled MEMCG, there was a noticeable overhead on some use cases. So all Android partners are not really on board with with enabling MEMCG on their production devices. Additionally, MEMCG performs accounting in units of page. In the DMA buffer sharing model, a process takes a reference to an entire DMA buff, keeping it alive, even if it is only accessing parts of it. So per page memory tracking feels like an unnecessary overhead for DMA buff memory accounting. Also, for our use case, there is no need to use C groups to track which processes are holding FD or map references to a DMA buff, since we already have that information available in ProcFS. So for the use case of allocator attribution, of DMA buffs, we don't really think that the memory controller C group is the right way to memory C group controller is the right way to go. So the next solution we explored was whether we can have a user space service that keep tracks of all DMA buff allocations and releases. So we found a couple of issues with this approach. The main one was that we could not find a sure shot way for the user space service to intercept all allocations and releases, because allocations in Android, DMA buff allocations in Android happen through the DMA buff heap ioctls, and a DMA buff is of course released when the last reference to it is dropped. So it would be very hard to have a user space service intercept all allocations and releases. Moreover, even if we were to have such aggregation happening in a user space service, in the event that the process gets killed or restarted for some reason, we would lose all accounting so far. So those are the issues that we faced with this solution. So the next solution we explored is the GPU C group controller that is under construction upstream. It seemed like a good fit for our use case. And in the next few slides, we can I can walk you through our evaluation of the C group controller for usage in Android. Okay, so since the GPU C group controller was actually created for the upstream GPU drivers, the API from the latest RFC is actually closely tied to the DRM framework. This is unfortunately a problem for Android devices, because in Android, all DMA buffs get allocated by the DMA buff heap drivers. So but if the original authors of the C group controller are on board and they don't mind doing it, it should be easy enough to change the API to be generic, though, to decouple it from the DRM framework. So yeah, basically we would need the API to be a bit more generic to allow it to be used by the DMA buff heap drivers. Okay, so the next issue we faced with using the GPU C group controller in Android is not really specific to the GPU C group controller. It mostly relates to the way DMA buffs are allocated in Android. So in Android, the majority of DMA buffs are allocated by a process known as the graphics allocator HAL, or the gralloc HAL as we call it. So multiple clients would request the gralloc HAL for an allocation over IPC with specific requirements and constraints, and the gralloc allocator HAL process would do the allocation keeping in mind the various constraints and send the DMA buff FD back to the client over IPC. So this is how the majority of DMA buffs get allocated in Android. However, this means that if we were to charge every DMA buff to the process which allocated it, we would not have effective allocator attribution for DMA buffs in Android, because the gralloc allocator HAL would be on the hook for the majority of DMA buffs that were allocated. So to get over this problem, we would actually need a way to charge a DMA buff to a C group other than that of the allocating process. So we explored a few different ways that we could do that. So the first solution that we explored was whether we can use the C group interface itself to do such a thing. So for example, the allocating process could write the DMA of FD to a file in the client to a file in the client processes C group. The allocating process would of course know who the client was. It would need to know who the client was to do such a thing. And yeah, however, we ran the interface by C group maintainers, and they did not feel that the interface was very upstreamable because it really differs from it. It does not match with how resource accounting is currently done in the existing C group controllers. So it did not seem like this was the way to go. So the next option we explored was whether we could introduce a new DMA buff heap ioctl that would take as argument the FD to the C group of the client process. So what would happen here is that in the ioctl handler, the heap driver could check whether the client's allocation limit has already been met. And if it has not been met, it will proceed with the allocation and charge the buffer to the client C group. And if the charge has already been met, it would fail the allocation. So we would use SC policy so that only SC policy restrictions to ensure that only approved processes can use the new ioctl, the new DMA buff heap ioctl. Another solution that we briefly looked into was to we looked into whether we can figure out a mechanism similar to f-advice don't need, where the allocator process can say that it will not be accessing this DMA buff at all, and then the DMA buff would get charged to the first process who accesses it. However, due to the shareable nature of DMA buffs, we did not think that the results with such a scheme would be deterministic. For example, the process who receives the FD over LPC from the allocator process might not map or install the FD and pass it over to another process. So it really does not fit into our use case of setting an upper limit for the DMA buffs which were allocated on behalf of a process. So we kind of, we just did not think that it would work out. So these are the various options that we explore to figure out how to charge a DMA buff to a process other than that of the allocating process. So yeah, if you have if you can think of any other approaches that we can try to implement the feature, or if you have any thoughts at all, we'd be happy to collaborate. So yeah, that brings us to the end of the presentation. Thank you. Questions?
So I don't mean to put people on the spot. I do see there's a few of the folks who are in the C group proposal in attendance here. So I don't know if Kenny or anyone else has any comments. Might be good to hear.
Yeah, I think we talked on email before. I'm okay with option 2. But I think it sounds like we want to separate out the C group control functionality from the GPU C group into maybe a DMA buff C group potentially. Is that what you're suggesting?
Yes, Kenny. So yeah, just like we discussed over email, we would like to make the API a little bit more generic, so other DMA buff exporters can also use it. So yeah, I would actually be okay with going with option 2 as well if the DMA buff and DMA buff heap maintainers have no issue with going that way. So then yeah, I think that should be a workable solution too.
So I don't know if it's relevant or not, or even if I understand the problem properly, but have you would eBPF fit in there somewhere?
So we looked into eBPF, Kareem. So the problem we found with, so I'm assuming you're talking about adding trace points and eBPF hooks to eBPF maps to have aggregate the accounting, right? So the last time we looked into it, we did not. So eBPF programs, they were not supporting locking. So yeah, concurrent updates were an issue with eBPF maps. So that's why we decided not to go with the eBPF map approach.
Okay, thanks. We got about 5 minutes left, so if anybody else wants to pitch in, now's a good time.
Guess I'll just ask the question of how far out do you think you'd be from submitting a patch for the list for something like the option 2?
So John, for us to go with option 2, we still need the first part to be done in collaboration with the GPU-C group controller, where we modify the API to be generic, so that the DMA buff heap driver can use it. So I guess our next step would be to follow up with the owners of the GPU-C group controller, and if they are okay with making the API generic, then we can we'll be happy to collaborate with them or take up the task of making the API generic or helping them in whatever way they want to get it done. So I guess that's the next step for us right now.
So there's another micro conference on Friday
Yeah.
around C group for GPU resources. So maybe that's another topic that can be discussed there as well.
Yes, Kenya. So I'm planning to attend that one too. So yeah, maybe this is something we could discuss there as well.
Okay, so maybe we want to switch slides. Okay, perfect. So we're open to sort of taking this up again on Friday, if need be. Thank you a lot, Herdia, for the presentation there.
Thank you, Gary.
Yep.
Okay, can you guys hear me?
Yep, loud and clear.
Cool. I'll wait for 9:15 to start.
Yeah, perfect. Thank you.
Okay, looks like it's 9:15, at least on my clock, so I'll start. Hello, everyone. I'm Saravana Kannan from the Android Common Kernel team. I'm here to talk about firmware dev-link, what are the remaining issues and what future improvements we could get from it. To do a quick status update, since the last LPC, firmware dev-link is now on by default, I think since 5.13. So that means it starts enforcing probe and suspend receive monitoring based on the dependencies it has gathered from DT. And to do that, it supports currently 23 common DT bindings. And there are about 55 or more patches since the last LPC. The changes that went in are basically to improve handling of cyclic dependencies. So it automatically notices a cycle and doesn't try to enforce the ordering because it doesn't have any additional details. And it also does a better handling of early devices that are needed for to bring up the CPUs and whatnot really early on in the boot process, like clocks and whatnot. And then it has a better handling of cases of missing drivers. And then it has support for optional dependencies. So there's for example, like IOMMUs and DMAs. And now, because of this, IRQ drivers can now be platform drivers and they can be modules and upstream. I talked about better handling of cases of missing drivers. So I want to get into that a bit more because it sets up the discussion later. So consider this dependency graph. A is the supplier of B is the supplier of C, and C is the supplier of D. And in this system, there's not going to be any driver for A. So by the time deferred probe timeout happens, the timeout expires, there's no driver for A. That's the case we are talking about. And B has an optional dependency on A, so that if A is not probed, B can still continue probing. With firmware dev-link equal to off or permissive, which is how it used to be before, once the deferred probe timeout expires, when B tries to get a resource from A, it's going to get E no dev or similar error instead of getting E probe deferred. So B will stop probe deferring and will actually complete probing. So this much was guaranteed with the firmware dev-link equal to off or permissive. But what it didn't guarantee is that C and D could fail probing even though they could have successfully probed, because they depend on B and like D depends on C. So once B probes, they really should be able to probe, but that's not guaranteed to that, or with firmware dev-link equal to off. That's because C and D could be attempted after the timeout, but before B is probed. So in that case, they'll get an E node of error, and then they'll just fail to probe. With firmware dev link equal to on, it kind of guarantees that B, C, and D will probe once the time mode expires. That's because firmware dev link on will enforce the ordering of probe between B, C, and D. So B will probe first. You'll see that A isn't there. It'll continue probing, and then C will be attempted, and then D will be attempted. So in that sense, it improves handling of cases where there are no drivers. Quickly, these are the 23 bindings that are currently supported. The last 5 of them were added this year, I think, or since last LPC. Going on to discussion slides, the first topic I wanted to discuss is fully asynchronous probing. Since firmware dev link completely disconnects driver initialization order or driver registration order from device initialization order, it allows us to do asynchronous probing in a much more reliable way. So what you see here is basically a graph that the x-axis is time, the y-axis is the CPU number. So it's like 0, 1, 2, 3, 4, 5, 6, 7, 8. If it's white, it means the CPU is idle. If it's any color, then it means CPU is actually busy. Darker the color, the more busy it is. That's what the graph is trying to show. And this the part that's kind of circled is the time where we load the modules and the devices get probed. So by the default asynchronous probing scheme, that whole thing took about 900 milliseconds. So when we kind of hacked up the kernel, or we actually went and changed all the drivers to enable asynchronous probing, we were able to actually probe successfully and get to a functional system, like the phone would boot to home screen and things would work. And it cut down the initialization time for that part of loading the modules and probes by 50%. So it goes from 900 milliseconds to 450 milliseconds. And then we want to try to take it a step further, where we basically loaded all the modules in parallel. And it kind of, in a sense, gave asynchronous probing for free, because every probe is done in the context of the thread that's loading the module. With that, we were not able to get a fully functional system, but it did cut down the time to 250 milliseconds. I think the reason we didn't get the fully functional system is because there are some issues in the error handling in the drivers, in the downstream drivers. So I don't think that's anything that can't be fixed. It should definitely be fixable, and 250 milliseconds should be a reachable goal. And you can see from the graph how the work is kind of getting more compressed into a shorter time frame with more parallelism. So my first question here is, what can be done? Or my goal is to try to enable fully asynchronous probing for at least DT-based systems and upstream. So do people have thoughts on this? One caveat with this is right now there's no global flag to enable asynchronous probing by default. So that would be something I would like to add to the kernel command line. Any thoughts, Greg, Rob, anyone else?
That would certainly be the first step to get anyone to use it.
Adding the command line, you mean?
Yeah.
Okay.
Yeah, that'll be interesting to see what happens. Yeah, it'll be fun to watch.
Yeah, I'm really curious. I would think the upstream would be in a much better state. So I'm expecting this to succeed in upstream, we'll see.
I want to see it. I want to see it happen.
I'm pretty sure that there was some flag. I experimented a bit with async probing by default, and I did manage to find a flag to turn it on by default. I think I had to search a bit.
I even dug through yesterday. I couldn't find any. Basically, you can have command line to enable a driver at a time, but you have to list the driver names, and the number of drivers you could list is limited by 256 characters. But I'd be happy to.
I managed to get something that turned it on by default, and I don't think I had to hack the code for it. But I'll look again for you.
Yeah.
But it didn't boot, but it did seem to turn them all on by default.
Yeah, I'm not sure when we tried it, but maybe with firmware dev link equal to on, maybe it'll boot. If it doesn't, we can kind of look into it.
There was an option. I thought we had it a long time ago enabled. Maybe that's a per bus issue.
Okay, yeah, we can.
I know
Yeah,
PCI,
this.
I think PCI could handle that, and we made it a bus option.
Maybe. Okay, so people seem okay with this idea, so I'll start kind of sending out patches for this in the future. I'll go on to the next discussion.
One more question for you.
Uh-huh.
you mentioned for parallel module loading that it wasn't fully functional, and you thought it was probably some driver issues. Is there a possibility that asynchronous probing will face the same problem? You just didn't hit it just by a circumstance of timing?
It's possible circumstance of timing is hiding some issues, but in the cases where we did see failure, they were like very obvious bad error handling code and modules. So that's pretty much frozen. So I think basically it can be fixed if you fix error handling.
So in that case, it might be useful to actually, at least on an experimental or development basis, allow the parallel module loading to discover those errors. And
oh yeah, we're doing that. Yeah, it's not, I haven't dropped out on that attempt. The goal is to get there, but I think asynchronous probing at a minimum that should be more feasible.
Yeah. Okay. Thanks.
Does parallel module loading require any kernel change?
It doesn't actually. Yeah, it didn't need any kernel change.
Have you looked at parallel init calls?
No, that's what I see. Well, parallel init calls. No, that's effectively kind of what it's doing, right? Parallel module loading, it's just moving the init calls after late init, and then you're doing them in parallel. That's
right.
What effectively it's doing.
But then it would help the static kernel case.
Yeah, it would. That will be interesting. I'll first get asynchronous probing working, and then I'll look into parallel init calls.
I did look up my old notes on this, and you're right. My last note said that there was no flag to turn this on by default. One thing I will note that I remember running into is you're going to run into some device ID problems. So when I turned this on, for all MMC devices at Ulf's request, and then it broke MMC device numbering. And that was sort of the final straw to add MMC device number aliasing into the kernel. And some people yelled a bit about that. But there is another one that I didn't solve, which is Mtd device numbering will also get thrown for a loop because, again, it's depends on probe ordering. And when you start asynchronously probing, that gets totally changed. So we'll have to solve that too.
But that's a good problem. Device numbering should never be deterministic. It should.
Oh, sure. It's a good problem, but people will need to solve it. I tried adding it for Mtd, and it actually got reverted because there were lots of people relying on the Mtd numbers, and there was no support for fixing the numbers. So for MMC, there was a way to fix the numbers, and that kind of got people out of their buying. For Mtd, there was not.
Well, what's using the numbers today? Who relies on these numbers? It's not a user space thing.
It's user space usually. I can go look up the patch for you if you'd like.
So, I mean, we created UDev for this 15, 20 years ago for that reason.
No one wants to do that. They just add more DT aliases so they get their nice fixed numbers.
No.
Well,
Pushback. Do not accept that. That's not okay.
Well, the fixed numbers actually are really, really convenient in a lot of cases when the user manual itself refers to something by number, and then having the numbers the same in the kernel really, really keeps your mind from having to work really hard. So,
but
for
numbers
instance,
people, we've done it through bust all the way. We have PCI device numbers reorder on the phase of the moon, right?
Sure.
Network devices, USB devices, these are not deterministic numbers. They never should be. That's why we.
But for things that are built into the SoC, like when you read the user manual of the SoC and it says, here's MMC1, here's MMC2, here's MMC3, and then you read the boot log and it says MMC2 maps to MMC1, MMC3 maps to MMC0, and
so then, we have the same problem with ETH0 and ETH1 being printed on the front of servers, right? It's the same. Right? It's the same. ETH0 and ETH1 were printed on the front panel of servers. This is not a new problem.
Yeah, and you can solve this by attaching a text label to the thing without making it also be the device number.
Right. Getting a text label would
solves
be
the
the
problem in a
ideal
more general way, because sometimes the labeling that you see in the manual, it doesn't fit into the format Linux uses.
So I think
I
a
mean,
text
these
label
are not
is
user space, but MMC0 isn't go out as the device that user space directly accesses, correct?
Sorry, quick time check. Do I have
All right, sorry.
how many more?
Anyway, the point is that should not be an issue. Renumber them randomly. Let people figure it out. We have the tools to handle it.
The ship has already sailed on DT, and it's not just the kernel that uses them. U-boot actually uses more cases than the kernel.
Just want to second Sarvana's intervention there. So just a time check there. So I think there are more issues to be discussed, and I think this would be good to pick up on Friday. So go ahead, Sarvana.
They have only 5 more minutes or 10 more minutes?
You've got 6 minutes to go.
And then questions 5 more, right?
6 minutes total. So it's your time to whatever you want.
Okay, so the next one is the case of booting with missing driver. So with firmware dev-link equal to on, let's look at the case of A is one that never has a driver in upstream. It's not even an upstream. And then B has an optional, B is actually listing A as a supplier in DT, but driver of B also never tries to get any resource from DT. So this is the combination. Does D probe? With firmware dev-link equal to not on, it'll probe all the time. With firmware dev-link equal to on, if config modules is not enabled, it'll probe. But modules is enabled, it doesn't probe. Obviously, because firmware dev-link doesn't know if it needs to wait longer for the module to show up or not. So a couple of ways you can get around this and get D to probe. One obvious one is set default probe timeout equal to 1. It'll notice, oh, A doesn't have a driver, it'll stop enforcing, B will probe. Or I can add another timeout thing and set the default to 1. One problem with this is if you have a fully modular kernel, that's where firmware dev-link equal to on would help the most. This will effectively make firmware dev-link useless because of the default will just cancel firmware dev-link after this timeout. It'll be useless. Another option is to set up a timer for 5 seconds after which firmware dev-link will stop enforcing, but then you extend it each time you load a module. So are there other ideas? What should be the response to people saying, hey, this is breaking my case? Should we ask them to use default probe timeout 1? Default probe timeout 1. Rob, I guess would be the first one I want to ask. I can re-explain it if it's too fast. If you're talking, you're muted, Rob.
Well, the timeouts always had problems when we've tried to set it.
But that's why I gave the other info earlier. So its timeout is a lot better now. It's not just going to blindly fail everybody. It's only going to fail. It's only going to allow or deal with this where there's no driver at all registered at that point.
Some systems take a really long time to get to module loading.
I know. So that's what I'm trying to.
It's like picking like 5 is going to be absurdly low for some systems, and it's going to be
No,
absurdly
but 5
high for
you
others.
extend. Okay. Yeah, if you're seeing the first module loading is going to take longer than 5 seconds, yeah, it's going to be a problem. That's just a number, but.
Yeah, it's like we probably just need to say like set a value though rather than set this particular number.
That's what I meant.
It's clear there's nothing magic about the number. We just made it up.
Correct, and then it will be configurable. But there's a third option of setting it and extending it better than the other 2 options. Any thoughts?
The only thing I've thought of is having some sort of file you can write to say I'm done with module autoloading.
Yeah, I've suggested that before as well.
But then, yeah, the default case would still not work, though, right? For the cases where
it would mean you could arrange for a good handover from user space boot, or from the kernel boot to user space though, because at the minute the reason you want a timeout is because we don't really know when user space is finished doing its initial go at things. Whereas if user space can say, hey, I'm done now, anything else, I'm not loading any more modules without something happening, then it at least progresses things.
Yeah, I know, understand, but then what do we do with this case? It'll still, by the default, if you don't make any user space changes, you're going to like block the probe of B. And there are a few cases like this in upstream where there's no driver for A either. So
I feel like we need some sort of way of annotating that as properly optional? Because just using timeouts for the optional links, I feel like is the problem that we had before. And so if there's some way that the driver can say, hey, this link is really optional, we don't care.
Can we annotate that? Would that be okay? Maybe, maybe 1 second. Would it be a chosen node thing where you could say, hey, these are all devices that Linux doesn't know how to do, and then I can just go through that and figure it out? Will that be an option? I see there's only 1 or 2 minutes left. Thanks.
Yeah, we're about to flip, so whatever you want.
Rob, okay. By the way, please join the Birds of Feather like on Friday. We can continue to talk a lot about this. Please.
Yeah, you still have 1 minute to go. Go ahead, Rob. Sorry.
Asynchronous probe, you'll have another problem here, because then your net calls being done aren't related to your probing being done.
Please attend the for BOF. Thank you.
Yeah, I think we're at the next presentation, which was the Android drivers in Rust.
Woodson, give you control.
Hi, can you hear me?
Yep.
All right, let me share here my screen. All right, so
perfect.
Yeah, I think we can get started, right? It's 35. Hello everyone. My name is Watson. I am a software engineer working on the Android platform security team. What I wanted to talk to you about today is writing Android drivers in Rust. So what I'd like to do is actually show you a few examples of snippets. I'll show you some C code and then some Rust code, equivalent Rust code. And I'll show you some examples. And these examples come from our work importing a GPIO driver and NVMe driver. The GPIO driver is published and available for all to see. The NVMe driver is not published yet. We plan to publish it soon. And then after I show you some of these snippets, and we don't have to go through all of them, I'll open up for discussion, and I'll have some questions that we may discuss. The first snippet I'd like to show is how you declare a driver. This is how we do it in C. We all know how this is done. This is a real example from the PL061 GPIO driver. And here on the right is how you do the same thing or similar thing in Rust. We also have a macro similar to the one we have in C here. The syntax is a little bit different. Most fields here are similar. Author is not here on the left side, but it would be like module author and some name. But the key difference here is that we have this type, PL061 device, which we implement some traits for, which I'll show in the next slide in Rust. So here's how in C you would implement your device ID table, and you declare your probe function that was referenced in the driver in the previous slide. In Rust, you do it this way. You implement this Amba driver. Amba is the bus. You implement the straight, and the straight is like an interface in Rust. So the core kernel defines this interface, and then drivers for this bus implement this interface, which is called the trait in Rust. One thing that I'd like to point out here is that the state is all typed. So in C, and it's not highlighted here, but the idea in C is that you allocate some state for this device that is being probed, and then you save it as driver data on the device. In Rust, you would allocate the state and you'd return it, and that would be stored as driver data, which is untyped in C, but is all typed in in Rust. Another thing that I'd like to show here on this slide is that we have a type here that specifies where the power operations come from if they are implemented by this driver. In this case, we're saying self, so it's coming from the same type, from the same PL061 device. Here's a little bit more details on how you declare device ID table and how you'd attach data to it. In Rust, we allow the data attached to each device ID to be typed. In fact, we require it for memory and type safety. And here, in this example here, we have U64 as the type, an example with a type with data, another example without data, and you don't have to null terminate your list. So it's one less source of potential problems. And then in your probe function, you get an optional 64 in this case, which is the same type as this. If you actually had several IDs here that had different types of payloads that needed to be attached to, then you could define an enum with data in them, which is also supported. Another snippet here, power management. This is how it's done in PL061. This is how it's done in Rust. You can see here that in the C version, we have this if def. If a PM is not defined, then these things don't even get compiled in C. In Rust, we don't really need to do that. This happens automatically. You can just define your code, and if PM is not defined, the code will not make it to the final binary in the end. Similarly to the previous examples, you implement a trait. In this case, power operations is the trait, and then as in previous cases too, the payload, the context of the power state is also typed, so you don't have to cast, and there's no chance here for you to cast to the wrong type. Another snippet here is how you do IRQ registration. On the left again, how you do it in C. On the right, how you do it in Rust. Most of the stuff is quite similar. The way you format things is slightly different. It's actually typed in Rust. One thing that I like to call out here is these extra the context that you attach to your IRQ handler. In C, it's untyped, so it's NVMe Q here. It gets cast to void star basically. In Rust, that's not the case. So in this case, it's ref counted. So we increment the ref count here, and we pass it to the IRQ registration. And then what we get back, we actually get back this thing that represents an IRQ registration that actually gets automatically unregistered when the object owning it is destroyed. So this is an example of automatic cleanup in Rust. Here's how the handler would be implemented. This is the C version. The Rust version, again, we have IRQ handler trait that one would implement. And here again, we have typed data associated with the handler, and this is guaranteed to be alive. If the IRQ handler has been called, then we know that this is alive, because the unregistration is the one that decrements the ref count on this referenced NVMe queue. Here it's not really directly related to the IRQ handling, but we use an enum to return the status of the IRQ handler, and there's no coercion from integers to enums in Rust, so they need to be explicitly returned as enums. Another example that I'd like to show is locking. So this example comes from the NVMe driver. Here on the left, again, we have the C, and on the right, we have the Rust code. In C, we have the explicit spin lock and spin unlock in the end. In Rust, we have this self-inner.lock that gets automatically unlocked when it goes out of scope. So in this case, down here, if we wanted it to be unlocked earlier, we could drop. There's a function that you can call drop to unlock this, or we could put a scope around it. the data that is protected by the lock is not accessible to code before you lock it. So there's no chance that you could access some field that is protected by a lock without actually acquiring the lock first. Here's something that I point out, which is really not related to locking, but it is something relevant to this example, which is here we have a mem copy and we have a size of CMD, which has the potential of having the wrong size here. We don't do that in Rust. This is a generic function, and it determines the size based on the type of the argument. And then one last thing in this slide is that we call this self SQDB, submission queue doorbell. But this function actually expects the queue to be locked, right? So in C, there is no way to convey this, right? Which means that somebody could actually call this function and not have the lock acquired. And that would be a problem. In Rust, we prevent that. We say we need the lock to be held. I think this is the last one, which is how you do memory mapped IO. Again, everything's typed. We don't mix return values and error codes. Resources become unavailable when the device is removed. I can talk about this more later if we have time. But this is the essence of the MMIO. Here we don't have arithmetic from the device driver doesn't have to write arithmetic. It's actually if we know what the offset is, which we do in this case, then there's all the checks happen at compile time. And if we don't know what the offset is from base at compile time, you only know it at runtime. Then there are try variants that may fail. If you specify an offset that is beyond the end of the buffer, then your read or write would just fail. So here I have we have 10 minutes to go, so I'll just go quickly over this one. I just have a list of things that of reasons why one might want to consider doing Rust. The primary reason we are considering it and looking into it is for security, but it also gives us increased velocity in development, because there's a whole set of errors that just can't happen in Rust by construction. This is really all I wanted to show. These are just examples. There are many more. Another thing that I like to say is that these examples come from the state where things are today. If we find better abstractions, better way of doing things, we are of course open to doing them. So what I'd like to hear from the community is whether you have questions on any of these things that I showed. If you have any concerns about the adoption of Rust if you have any concerns about the adoption of Rust in the upstream kernel, if you have thought of unforeseen difficulties, things that we haven't thought about, general feedback. Another thing is pain points that you may have in writing C drivers. I'm very interested in hearing about those, because we can see if we can improve the experience in Rust. Also, we could discuss possible paths to upstreaming this effort. Yeah, so I'll stop here, and I think somebody had.
No, this is Trilok. I was just kind of unmuting. Just so this is from Trilok from Qualcomm, and we did submit some of the sock info drivers, which is kind of non-hardware based. But the next, which we'll plan to submit, is somewhat IRQ based, but most works on the ARM systems, and it's more of our Qualcomm SoC hardware blocks like IPCC and last level cache controller. APIs basically, so both are unique in a way. We do not, of course, hope to get replaced our C drivers right now, but that will give you some sort of guidance on how it works on the real Qualcomm SoC, basically. Of course, it's already working, whatever you have with one driver we submitted recently. And of course, there are some improvements to be done. But yeah, maybe in coming weeks, the next plan is to play with the bootloader. But again, that's maybe out of scope from here.
Yeah, thanks for submitting that. one thing that I thought when I saw that, and Miguel sort of touched on it, I thought it was great that you guys did the work to port it. One thing that we're trying to do is to actually build abstractions. So instead of calling the C functions directly from drivers, which requires unsafe code, what we're trying to do is we're trying to wrap all these C calls into Rust abstractions, and then expose those as safe abstractions to drivers. So part of our goal is to reduce as close to zero as possible, although we can't reduce everything to zero, the number of unsafe calls from drivers.
Yeah, so it's more of we are looking for more of how do we integrate the tool chains. The current problem we face is not really kernel specific. It's about how do we integrate the tool chains into our existing manifest, which is pretty much looks like a Android kernel manifest, what you guys have on the kernel side, but it's more of how do we integrate it outside of the Android build systems. Basically, we do not really want to have it. So, and that way we can more of make it work for some of the systems programming projects, which is outside of Android. So anyway, that's another set of things to look at, but that's more of outside of upstream Linux kernel Rust program. But yeah.
Cool. Thanks, Trilog. Good to know. There's more happening in Qualcomm. There's some activity here in the chat. I don't know if they're talking about this or something else. I think they're talking about the previous.
I was kind of curious, just as far as the process of kind of migrating, how you've had it, learning Rust. Some of the stuff like the scoped locks, I find really unintuitive, just because I've been, my brain's in this pattern matching of finding a lock and unlock and matching that, in every driver. And so having these kind of subtle aspects that you see in like C++ kind of creep in can be somewhat concerning. So I don't know how much that's difficult to kind of adjust to, or is that something that you feel wasn't too hard?
Yeah, so I've had similar feelings as you, John. I'm a C programmer, and one of the things I disliked about C was that it did things under the covers, right? That's how I felt when I used some of these patterns. But there's actually one aspect in which Rust does things differently from C++ with respect to logs. It's that when and I didn't show it in these slides. I show it in a different set, but we actually have to separate what are the fields that are protected by some log, right, into a different struct, and that becomes a field in your struct with the wrapped in the lock, right? So the idea here is that there is no syntactic way, like you can't write a program that actually 5 minutes, thanks. There's no way for us to actually write some code that access those fields just using the safe fragment of the language without having to go through this lock. Now, having said that, you can actually, if you want, have the lock and unlock. You can actually define those. You can go in your lock definition and the guard actually, and specify an unlock function, for example, that consumes the guard, which means that the data is unlocked, so it's not available anymore after that point. So if people actually find that really unintuitive, and they like to see unlocks, or they'd like to write the unlocks, it's certainly something we can do. We can expose these sorts of things. And in fact, something perhaps that we should discuss, if it's something that most people want to see, we can do something like that. But actually, answering your question of getting used to it, I thought it was okay getting used to it.
I had a more fundamental question regarding the sort of motivation for this. It seems to be like security based. And maybe I'm wrong, but my hunch has always been that security is not a very good driver for stuff inside the Linux kernel for driving topics. And I was wondering if you could speak a bit about that. And is there any other motivation other than just security? I mean, what's the other benefit? Is there another sort of good, compelling story to this than just security?
Yeah. Thanks, Karim. So the thing is, Rust has actually a fundamental difference from other widely used languages for doing low-level systems, right? And that difference is the memory safety without the garbage collection, right? So this actually allows us to eliminate by construction a whole set of bugs that one would write. And this is compelling for security because this set of bugs are usually, and there are some statistics that Miguel had posted, like 70 to 80% of all the vulnerabilities come from these memory safety issues, right? But this is actually a fundamental difference between Rust and C and C++ or any other language that have been languages that have been used to write kernels. But as I tried to show in the previous slide, these features of absence of actually memory safety and absence of undefined behavior doesn't help only for security, it actually helps with correctness as well. So it improves, thanks, just 1 minute left. It also improves the velocity, as I was saying. People sit down and want to write code. A whole bunch of things actually disappear. Data races is an example. We don't have data races in Rust. If you try to introduce a data race, Rust catches it at compile time and prevents you from doing it.
So would you say that writing drivers in Rust is more user-friendly and more approachable than writing them in C?
Yes, yes. I would say that's the case because there's less things that you have to concern yourself with, so you can focus on driving your device rather than, oh, can this API here cause me trouble in terms of inserting vulnerabilities in the system, things like those.
Well, for what it's worth, I would say that for me, I think that would be better selling point. This marketing side.
Yeah. Thanks for the feedback. It's good to hear.
Yeah, there was somebody else. We can go for the question. There was nobody behind you, so we're going to go for break afterwards. So go ahead.
Go ahead, Miguel.
I just wanted to comment, especially for maintenance. As a maintainer, if you are reviewing a change to the driver, it's much easier to take a patch in Rust, I would say, because you don't have to worry about it.
Yes. So yes. So this is a good point that Miguel makes. In Rust, so we have this safe subset, fragment of the language. That is what we want most people to do. But then in certain cases, we may actually break the guarantees. So in those cases, we specifically have to annotate this code as unsafe, right? So there's like an unsafe curly brace and then some code in it, which means that every time you're going to review some code, when you see that unsafe, you know that you have to pay attention to that piece of code and review it carefully. And the rest, you know that wouldn't introduce vulnerabilities, memory-related vulnerabilities. Yeah.
All right, excellent. Thank you. So we are going for break, and when we come back, it will be 10:10 Pacific. I can't remember what it will be, UTC, but we will start with the speculative page faults. All right. So thank you all. There we go. 5:10 p.m. UTC. All right. Thank you, Watson, and we'll see you guys back in 15 minutes.
Thanks. See you in a bit. Hi, Michelle.
Hey.
Yeah, I'm just switching you
yeah.
over. Alrighty, so you should have presenter access now and you should be able to switch your slides.
Yeah, that makes sense. Thank you. I'm just gonna, yep, that works.
All right, Michelle. I don't think it's about 10:10. I don't know if Karim's back, so if you'd like to, the floor is yours.
Yep, thank you very much. So, well, first, thanks to everyone who's here. My name is Michel Espinas, and I'm going to start with a quick disclaimer. This is work I did while I was employed at Google. I'm now a Facebook employee, and this talk does not intend to represent either company. So, this work was based on ideas that were worked on previously by Laurent Dufour, Peter Zilstra, probably others before that. And Laurent Dufour presented a patch set about 2.5 years ago. It was deemed too complex for inclusion upstream at the time. That was at LSFMM 2019. And but many Android vendors picked it up because it was shown to improve application startup performance, and that's an important metric for these systems. So I came into this trying to come up with like a minimal version of these ideas, something that would be easier to get accepted, ideally, have less complexity, be more bisectable, that sort of thing. All right, and well, so I have a patch set that the version I sent is based on 5.12. I actually have more recent code I need to do more testing on and send again. So I'm gonna first explain a little bit of how it works. So in a page fault, in the regular, code without this patch set, the page faults are executed under mmap readlock, and they might need to do things like, typically they will allocate a data page, and that might be slow if you have memory pressure. And while that happens, you can have other threads modifying the VMA tree, for example, creating new mappings during application startup, even if they really want to work on a different part of the address space. And and that is kind of where we see these delays in application startup performance. So what the patchet is doing is that it tries to execute the pagefall pass without taking mmap_lock in the common case. And so the viters will be able to execute. And in the pagefall pass, well, we do have to be a bit more careful because there might be viters, you know, doing stuff that will interfere with us. So we need to be careful. But in the end, we will do some sort of transaction that will either succeed and atomically commit the results at the end, or it will fail, and maybe because there was an interfering viter, or maybe because that's a more complex case that we don't have speculative path for, and in that case it should abort and we will just retry in the non-speculative way. I have a few more details on that. So in a normal pagefall, we take the mmap read lock and we find the VMA, we check the permissions, then we go in handle mmfall, so that does things like walking the page table, finding what's the original page table entry, and then we do handle a PTE fault, and that will resolve the fault in a number of different ways based on what's in the VMA, what's in the original page table entry, and the type of access we're doing. And only when all that is done, it will release the mmap_lock. So for example, in the anonymous page case, that would be if there was no PTE originally, and that's an anonymous VMA, then it just allocates a page, locks the page tables, inserts that page into, well, after locking the page table, it has to check the PTE hasn't changed, because there might have been another page fault running concurrently that already resolved the fault for that address. But if the PTE hasn't changed, then it will set the PTE to the new data page and unlock the page table, and that's how the fault is resolved. All right, so now we want to do all of these things, but without having the mmap_lock. So there's a number of things we have to be careful. And well, the first thing we need is to have a way to know if we interfered with any viter. And for that, I just have a sequence counter that every viter will increment at the start and at the end of the vite. And so this is done just by instrumenting the mmap vite_lock and vite_unlock functions, so that it's very easy to know that we accounted for all log sites that way. And then we have to be careful about viters that might free the VMA. So to protect against that, we make the VMA freeing RCU safe. We need to be able to look up VMAs without having the lock. So it turns out that we can do that by just doing find VMA under the RCU read lock. So because we have the RCU read lock, we know we won't find any freed VMA, so we won't crash. Now, if someone changing the VMAs at the same time as we do that, we might end up getting the wrong VMA at the end, but we can check the counter and check for that. So if the counter hasn't changed, we know we had a successful lookup. If the counter changed, we may have any random VMA, and we just gonna retry non-speculatively. And we also need to be careful about whenever accessing page tables. Someone might be running unmap while we're doing our page fault, so we have to make sure the page table stay there. And there's already code in fast group that does that, the short version, we have to either use RCU to protect the page table. That happens in power word case, like there's a config options that makes that happen, or by disabling local interrupts, and then that prevents TLB shutdown, so that prevents the page table from being freed indirectly, but that's, yeah. And then at the end of the transaction, I did point out there's this little place where we take the page table log to insert the PT. That is the point where we can do synchronization. We have enough atomicity at that point. If we just check the sequence counter after obtaining the page table log, and the sequence counter has not changed at that time, we can just insert our PT and terminate the page fault transaction. So that's the short version of how this all works. Now there's been, so I posted that was in April. There's been some test results that have been posted by MediaTek and Qualcomm that show some positive test results. MediaTek had some application that goes up to 31% faster for startup. Qualcomm had a number of applications they tested that went from 10 to 18% faster. It does seem to have the benefits that were already present in Laurent's previous version that a lot of vendors have accepted. And so I would like, I would like to push harder for that to be accepted. I do believe this patchet is generally ready for upstream, at least for the Anon VMA part of the patchet. I have some extensions to that look into file pages, and that's a bit more fancy, a bit less less done. So I would not be pushing for that right now, but I think the Anon path has a good case, and I would like to get more comments about upstreaming it. I was told to leave some time for questions, so I think I'm done with my presentation. I would like to know what comments anyone has, and I'm gonna open it for you.
Question is there some kind of workload where doing speculative page fault actually might cause regression?
Yes, if you look for it, that's going to happen. So generally, if you do things that are page fault intensive, we tend to see improvements. Now, you might see regressions in things that we don't have a speculative path for. And right now, since in the patchet I'm sending, I only implement the Anon case. So if you hit files, it might have to retry every time. Usually you find that very fast because you do your VMA lookup at the start of the fault. You see that it's not a case you will handle, and you can and it will abort right away. So the regressions are limited, but yeah, if you look, so yeah, if you look enough, you can find some regressions. Yes.
Michael, I thought the reason that Laurent's patch wasn't accepted was that there was a regression when it was a single threaded application.
I have not seen that in my version. There can be small, very small difference, like in single digit. I have not seen large regressions in single thread with my version. So when I detect single threaded case, I actually disable some of these things because they don't actually help in the single threaded case. So in that case, we actually don't speculate and we go directly to the non-speculative path.
Okay, and you said if the VMA changes, it restarts. Is that on the VMA changing or the sequence number changing?
Yeah, so the detection is not precise. It's just based on the sequence number. I can expand a little bit on that. So if while the page fault is going on, some other writer changes another completely unrelated part of the memory, that will increment the sequence counter, and the page fault at the end will abort, even though maybe there was no actual conflict if they worked on separate parts of the memory. If you think of the Android use case, it turns out usually not to be a problem because if the page fault took a long time, usually that's because it had to allocate memory and it hit a reclaim path. And usually if that's the case, like you will need to allocate memory either way. So like it ends up, you end up having to retry, but the work you did was not really wasted. Now, it would be nice if we could have a precise test that would let the fault proceed if it's a false conflict. That's not always trivial to do. I did have a slide, kind of a backup slide that goes a little bit on that. So that's if you break copy and write. Man, I'm gonna have to talk about it at least like 3 minutes to really answer your question. So if you break copy and write, there's this thing where you take a reference on the original data page, then you unlock the page table, you make a copy of the original data page, and then you lock again and you try to replace the original with your copy. And in the non-speculative way, the whole thing is protected by mmap lock, so there cannot be any writer making changes to that page while you make the copy. Now, if you do it speculatively, it could be that while you make the copy, someone changes the permissions, makes the page writable, writes into it, makes it read-only again, and at the end, when you're ready to commit your copy, the PT is still the same, but the data has changed while you were making your copy, and you could have some corruption that way. So there are cases, so it's not trivial to always handle to always reliably detect if you had a true conflict or not. And because of that, I just went for the simplest way of just using the counter, because that worked well enough for the Android use case.
Right, and your Android use case, that's startup time that was increased, right? It wasn't runtime multi-threaded applications?
That was mostly start time that was measured.
Okay. I was just wondering if you have something like, I think the eBusy test creates a bunch of threads and reads through the VMAs and edits, modifies one. This wouldn't help, would it? Or would it?
I do not remember. I do think I run eBusy. I don't remember what results I got. I think Qualcomm had a 10% eBusy 64 improvement that they posted, but yeah.
Okay, thanks.
Michelle.
Yes.
So I just, sorry. I just regarding Liam's question about the single thread use case. I just checked your results for get checkout, and it seems just like it was just a 2% hit, so like nothing too concerning.
Yeah. Shakil?
Yeah, Michelle. So there was a question from Shakil on chat, which is, what is the current potential blocker for merging this work upstream?
Yeah, so I did post a first version of the patchet. It included also the file cases that I think are really not as baked. And so there was some pushback there, which I think made sense. I have posted a newer version that really just does add-on. I really didn't get many comments on that, so I think there's review bottleneck, and I haven't pushed enough. I was switching jobs; it was a bit complicated. I think that's a review bottleneck mainly. Yeah.
It's fine. You can continue, but it's just we're going to switch pretty quickly. Go ahead.
Yeah, I just thought of it as a review bottleneck. I don't think there's any major obstacle that I can see other than that. I was hoping that people who objected to SPF 2.5 years ago, so that's mostly SUSE faults, could have a look at this patch and see if their objections at the time for complexity have been resolved, but they really have not had time to look at it, and I haven't pushed more.
Okay, thank you, Michelle. So we can continue the conversation on Friday at the BOF. We will be switching to John for the Improving AOSP Dev Board collaboration.
Thank you.
Alrighty. Hey, so I'm John Stoltz, and I work for Linaro, and this is my talk on improving AOSP Dev Board collaboration. Thanks, everybody, for making it through a long session, so hopefully this one won't be quite as technical. So when folks talk about AOSP Dev Boards, usually they're talking about kind of the smallish set of devices that are in the AOSP source tree that are supported in AOSP directly. I have them listed here. It's not a huge number, and it's maintained by a smaller set of different teams. But outside of AOSP, there's still a lot of devices and dev boards that folks are taking a number of different efforts to try to get AOSP to run against. We've got Global Logic's GlowDroid effort supporting the Orange Pi, PinePhone, and the Raspberry Pi devices. There's the various upstream form factor efforts like the Poco F1, OnePlus 6. 96 Boards has like a community AOSP build for the Dragon Board 410C as well as the 820C. There's the Android RPi project, the So Mainline project, and I'm sure others. I apologize if I don't have your project listed here. Now, being an AOSP, it's great, but there are a few minor issues that we've run into over time. One aspect is that all of the submissions we have to get Google developers review and help with merging. And this, it's one of those things I don't necessarily mind, but it requires a lot of back and forth with Google developers, which they might find a little laborious. They basically have to review it, approve it for pre-submit testing. Unfortunately, TreeHugger, the pre-submit test tool, regularly sees failures. Sometimes it's just the entire tree, something else is wrong in the tree. And the problem there is that there's no external visibility to the debug log. So we then have to go and bother the Google developers again to say, hey, did I do that? Is that something, that is just the trees down? And then even if the pre-submit finally does pass, there's only like a 2-day window for it to be valid. And so we have to kind of get the Google developers' attention again and ask them to push the button to merge it. And so it's just one of those things where I don't think any of the Google developers would complain about it, but it does make it clear that it's a burden a bit. They have other work to do, and we're kind of constantly nagging and pestering them. Additionally, some of the, I guess, maybe theoretical benefits that we were kind of hoping for being in AOSP didn't quite play out. So one aspect is that, when changes or requirements are made inside of AOSP, it's not something that those requirements, they don't go through and necessarily force every device to move to them. There's kind of every device is owned by its own kind of maintainer, and that's left to them to do that. Additionally, the dev boards are not necessarily used deeply for pre-submit testing. So when we see regressions, it's usually after those changes have landed. Now, the Google developers are really helpful in trying to help resolve any regressions that their codes might have changed or their changes might have caused. But again, if it's something that is just something off in the device directory or something else, it just can sometimes feel like you're on your own. Additionally, AOSP, it is really hundreds of Git trees kind of taped together with repo tape. And so it's one of those things where there's no way to really even clearly bisect a problem. So when you have a regression, it could have been in any one of these number of Git trees, and they often have cross dependencies. So it's not something that's easily to narrow down what's exactly wrong to try to flag the developer to help figure out the solution. And additionally, just keeping up with AOSP is difficult. I recently gave a talk at Linaro Connect on this. You can see at the link. But Dimitri Schmidt, who worked on the original Heike effort in Google, he kept some stats and found that there was about 2.5 AOSP regressions that were hitting each week. And this is great. The boards are doing their job and they're finding lots of bugs and getting those fixed. But the hard part was if anyone takes a vacation, like when you come back, the board's not going to be working. And so just the pace at which AOSP moves is immense, and so bit rot is a real issue. Now, the way that Linaro kind of handles this is that we kind of leverage our experience across our devices. So if we see a problem on the Heike 960, it's likely we're going to see the problem on the Dragon boards. And so, it's one of those things where we try to share knowledge between folks in the team to be able to kind of quickly solve these. We also share this knowledge with folks who are working on the upstream form factor efforts, as well as also with other teams like the Yukawa effort that the Android TV and Bay Libre developers maintain. For example, we borrowed the Yukawa audio howl for the Dragon Board 845 because it was better than what we had initially. And we've helped them a little bit with some of the GKI efforts as well. And we're also working closely with some of the Android TV folks on trying to get the V4L2 codec 2 support going. So it's one of those things where I think this cross-pollination and sharing is really important and kind of critical at times. Let's see here. So my big Linaro idea is maybe we should all work together. Whether we're in AOSP or out of AOSP, I think it would be good to have a bit of a community where we can kind of share our experiences and our debugging, and maybe even find ways to share effort and create better generic solutions. So the initial grand idea is something like an external AOSP tracking community. So this would kind of leverage a lot of the ideas of Lineage OS, but it would be AOSP focused instead of focusing on Android releases. This would allow us to be able to add boards at different quality levels without necessarily having a lot of tight interlock with Google. We would, of course, need some rules for acceptance for what is required to be included, as well as, if a board's not building for 2 weeks, it's probably time to remove it. So we need those sorts of standards. Additionally, I think one of the ideas from Glodroid is really interesting, is that Glodroid is really ahead of AOSP in a lot of ways because it uses upstream branches for a number of the external AOSP projects, things like Mesa and libdrm. And I think this is really useful because it kind of, in effect, is the Linux Next of AOSP. And I think it would be cool to have that sort of integration where we're able to kind of have a proving ground for both the upstream projects as well as new dev boards and being able to test all of that out before any changes necessarily get to AOSP. Some of the benefits here, I think, this would greatly reduce the burden on the Google developers. It would also provide a wider set of hardware for folks who are doing any sort of prototyping against AOSP to select against. They wouldn't have just the small set that's in AOSP. And then also, again, hopefully would have more shared cross-device effort, things like generic howls. So I did float this around inside of Linaro and with our members, and a lot of folks thought this was, sounds like a good idea, but it isn't something that folks are likely to fund. And so it's one of those things where, we would need some hosting and infrastructure if we're going to do any sort of enforcement of building rules or booting testing. We're going to need CI loops and labs and staff, and so that's going to cost something. Additionally, I think while all of the different projects out there are kind of doing similar work in their own corners, it's not clear that everybody really has the same vision necessarily. So we would need some sort of governance. The last thing I want to have is everybody kind of into one project and then just start arguing with each other. And additionally, for Google at least, the NAOSP dev boards aren't really going away. It's one of those things, they see it as useful, not only for testing against AOSP, but they also use it for testing internal branches, which wouldn't be possible with any external project. So scaling back a bit, figured, maybe we could have some sort of lighter weight collaboration. Maybe it's something just as simple as a wiki so we can just find each other and have a place where people can kind of list their projects and what devices they're working on. Having something like an IRC channel or a mailing list, I think would be really useful to kind of do some collaborative discussion and troubleshooting. It was proposed maybe a shared bug list would be useful. And that might be something we could look at. We might even be able to just add a tag to Google's issue tracker, and that might be a way to do that. So yeah, so that is the extent of my proposals at this point. I wanted to open up for discussion and thank everybody for listening. So I guess the floor is open for ideas or questions there.
I just have one question, John. What would be your preference to what can be changed?
I'm sorry, could you say that again?
What would be your preference in the ideas that you mentioned about what can be changed? Is it one or all of them? Like, for example, the shared issue tracker is one. The collaboration, like, for example, from my experience, we can, we always mention the emails and whatnot. I'll tell you what, there's not much email traffic we get. There are exactly 3 people whom we hear from, or one of them is you. So we are all up and open to do everything that you suggested. I think that's a great idea. The only worry that I have is whether or not, or how much do we need it? Because we've never been able to figure out how much it is needed by people, because we'd never hear from people around it, at least from Android or Google side. We've had our emails, like, for example, if I look at my kernel team at android.com email, there are probably no more than 10 emails in a year, and not even a month. So yeah, we can have an IRC, we can have issue tracker. It's very easy for us to do. The only thing is we just never had the need to do that yet. If there is such a push and there is such a need, I think we'd like to hear from everybody, and then we're happy to do it.
Yeah, and I think, to some extent, I think the hope here is that, while having the email for the Android kernel team is great, that's not something that's a publicly available thing. So it's one of those things where it's good for engaging with Google. But I think the aspect that I'm trying to figure out is how can we get more of the various disparate groups who are doing AOSP-based development outside of AOSP, how to get kind of everybody collaborating in a way that they can kind of interact together, because I feel like there's just so many cases where you just find on GitHub some tree where somebody already has solved a similar problem. I know looking at the Glowdroid project is really interesting, because they've got a lot of great solutions in there that we had to look at. So it's just something I feel like there's an opportunity for more shared effort there.
What about the individual vendors themselves? I mean, the silicon vendors do have their own teams doing this stuff, and honestly, for working with a lot of customers that use those trees, they're often sort of ancient and not so well sort of maintained. And I don't want to name anybody here, but is there any sort of outreach effort that could be made to possibly coalesce all this effort into something more coherent, in addition to the community folks that we're talking about here?
I think one of the issues there might be just the focus. And so I think a lot of the vendors are likely focused on the next Android release rather than on AOSP. And again, keeping up with AOSP is very difficult. So I can understand them not wanting to kind of have 2 efforts going all the time on that. I can't really speak for particular vendors on that.
Some of them have dev boards that are out there, you know, and are not necessarily, you know, next, but rather sort of, you know, back.
I think that just mostly speaks to how hard it is to keep up, because it's much easier to target a fixed Android release, make a, you know, release and sell a board, and then just kind of be done. You know, trying to keep up is hard.
Yeah, because this is one of the things that we get as a request is like, okay, we are choosing, you know, silicon vendors as chip X, Y, and Z. They have a dev board, but, you know, it's that version. We'd like a newer version. Can you do that? I mean, that sort of stuff is standard that we see. And I can't imagine that there's no way to sort of maybe entice those players. And then we can, you know, discuss some names offline if you want, to possibly join in some efforts like that.
See, Laurence brought up the Meson-based build system as well, and that's kind of also been a big pain point, and kind of one of those points that I said that, you know, it's kind of hard to necessarily figure out how to align everyone's different vision on this, because I know the Android build project is opinionated on what they want to be able to use for their build system. And integrating with Meson is not something that we have a great solution for right now. I know there's been some neat work in the Mesa project by Roman Stranko of the Glowdroid effort to try to enable that, but that's still something that it lets Mesa be built with Meson, but kind of not within the proper hermetic AOSP build, at least to my understanding. I need to spend some more time with it.
For the things that you list here, at least a wiki, IRC channel, or mailing list, is there anything preventing you from just doing it? Would you think it should be like a Linaro thing, Android.com thing? I have no idea. So
it's one of those things where I this is what I'm kind of just bringing up to the group here, because you know, I want to make sure that we're including folks who are already out in the community. So, you know, I feel like Linaro and Google have a lot of interactions, and, you know, want to make sure we kind of have other voices in there.
Right. One of the things that sort of keeps coming back as a need for documentation is sort of like some of the flags that are used in the board descriptions, like build_foobar. And then people ask, you know, where does this document it? And my only sort of good answer is, well, grep the sources for one of the Pixel devices, which is not sort of super satisfying. Because it's sort of like it's like magic, and any documentation I think about that would be very, very, very useful.
Yeah, I very much agree. That was a couple points in that talk I linked to cover a lot of the things that I kind of see as potential improvements to documentation we might be able to do in the future.
Yeah, I think we've taken that feedback last time as well. So for what it's worth, all of our documentation is now kept up to date live, at least from system software perspective, on source.android.com. The thing is, there are two problems with it. Is that we can't necessarily say it for all of Android, but generally your board ends up dealing with what we do a lot, because once you get past that hurdle, the framework more or less just works and you don't have any problems. But there is one of the other feedback that we took last year, which we did a slightly better on, but still haven't done as well as I would like us to do, which is to actually have that documentation link and relate to each other to make it easy, like what Karim mentioned, easy to find. Now, so if you go to source.android.com and like start with the architecture, you'll see everything we do, including dev boards. But there, it's still riddled with some problems where some documentation may be obsolete, and some may live in readmes in individual projects that get linked back and forth from source.android.com. So yes, we absolutely understand this is, but it'll take a while. We've been doing this, and we've at least for the last year and a half, and our documentation is now live updated with the code, which also then brings up with new set of problems where now it's too up to date, because then it keeps changing. Because we've heard that too. But there is a conscious effort, at least within Google and Android, to keep the documentation up to date as we make AOSP changes, and we keep it up to date in relation with AOSP and not with each Android release. That has also triggered a lot of alarms with people. Like, for example, Android 12 may be out in a few months, but so all the documentation that you'll see, some will reflect to what AOSP is right now, but people are still using Android 11, and they say, "Oh, I don't see that," and where is that? I don't see that in my Android 11 code. So there's always a mix. It's a mixed bag of problems that we have. So we don't know which way to go, whether we keep it and only update it at the time of release, or whether we keep it up to date with AOSP because AOSP is being used by other people too. So, but yeah, we're figuring it out. And if we try to keep it separated per release, then writing documentation will probably take more time than writing the code that the documentation describes. So yes, we hear that loud and clear, but hopefully it's been better. We'd like to hear feedback on what's missing, at least the big ticket items. For example, the GKI part was one, which I think Kareem flagged last time. There is no one place where if I want to start developing on AOSP kernel, where do I start? So we made it part of the kernel README itself and start from there. But I know that a lot of it also exists on sourceandroid.com and it doesn't interlink properly. So we're working on that now.
Yeah, I think I'm sorry, if for source.android.com, I think one thing that would help is if it's checked in, which I assume there's some sort of there is a sort of a repository behind it. If you could just tick and say, okay, I want version X of the documentation, I think that would help people that are sort of looking for the information for version, whatever, it's sort of gone by.
There's some questions on the chat too.
Yeah, I was going to say, Kevin's asked basically with the HALs kind of always evolving inside of Google, but not necessarily publicly, how do we collaborate better on the new HALs if we don't work for Google or Linaro?
Oh, the HAL interfaces, 99% of them are actually contributed to AOSP directly. So that's where you'll probably see newer HAL interfaces already now in AOSP that are not part of Android 11, for example. And Android 12 isn't officially out yet. So you'll see new HAL interfaces. So it's always in AOSP. Just follow hardware interfaces. There's two projects, hardware interfaces and I think framework interfaces. That's where all the new HAL interfaces are.
So the example I had in mind there was the Codec 2 HAL, which is not functional in AOSP, and it's not coming until Android 12, which isn't public. And so those ones, when we have boards that have the upstream kernel features that are ready for Codec 2, there's no way for us to work on those until Google decides to push that stuff. Right, so this is an example. So especially these upstream focused drivers where we're trying to actually have the upstream kernel ready for AOSP, but we can't actually see the HALs or work on the HALs. This is a potential for better collaboration is what I'm getting at.
Absolutely. So one of the things that we do is for all hardware interfaces, all the HAL interfaces that show up in AOSP, I think we make sure that there is at least one, if not a full implementation, at least a mock implementation of it that runs in AOSP. And and that is Cuttlefish. If people who don't know what Cuttlefish is, that's a virtual Android platform. That's how Android gets tested at scale in AOSP. So if there is a HAL that lands in AOSP and that doesn't have a Cuttlefish implementation, that's something that we would like to know, because that's the whole idea of doing this, to making sure there is a reference implementation landing with the interface. So people can then use that reference implementation to implement their own HALs and then report problems if they have it. But of course, there are some cases, some HAL implementation may not be possible in Cuttlefish, but we've been able to find solutions for pretty much every one of them. So me and Alistair is probably not there. We'd love to know if that is the case, that you saw an interface land in AOSP that doesn't have an implementation at least. There should at least be a Cuttlefish implementation there.
By the way, we're sort of just in terms of the MC itself, we're sort of past John's talk. So there's like a 20-minute slot which is open for discussion. So we can continue this for this one. If there's anything else that people want to bring back or anything in the questions, it's completely open at this point.
Yeah, I
Just
think it's
one
only
quick
10 minutes, but I
question
did want to.
Just one quick question before people drop off. For BOF, are we kind of planning slots for what to talk about when, or how do you plan to handle that?
All right, so what is the plan for the BOF? We did not sort of, honestly, since we were sort of struggling until the last minute to get it actually scheduled, we didn't get the chance to talk this over. Todd, John, and the other folks and myself. I'll just throw this out there. It's not definitive, but my assumption would be sort of just going through the topics that we had in the order that we had today, and sort of opening it up and sort of putting a few bounds there just to make sure that other topics get the chance to be discussed. If somebody else has a better sort of proposal, it's all open.
One additional note: can we maybe take a list of things where we know for sure we need to have discussions, and then maybe assign
Yes.
slots?
So, Sarna, I've already made that list while taking notes. So I'll share with the MC organizing team, and then we'll probably push out something hopefully by tomorrow.
Thank you, Sumit.
Yeah, perfect. Thank you, Sumit.
Sure.
So again, it's an open discussion slot. We have 17 minutes to go. You're free to bring up any topic that we have not discussed fully, or anything else that you would like to discuss. Afterwards, it's sort of the recording ends, and sort of we go offline in terms of YouTube live streaming and the professional production team that's behind that. So at this point, I'll just mute myself and turn my camera off. But you're welcome to sort of jump in and take the floor.
There was a question. Yeah, there was a question from Caleb that I've already put in notes, which is basically, are there any sensible standard ways currently to easily share HALs between devices? So like audio HAL, tiny HAL was discussed. Do we want to discuss it here, or is it okay to discuss it over chat?
Yeah, that's one I'm kind of interested in as well. I know sometimes there's been some hesitancy, I guess, to add new Git trees to AOSP. But I think if we have a couple of devices that are using it, I think it's an easier thing to, push for. We just have to be able to get Google to agree to it. So it's a little involved.
I'm sorry, I didn't really understand what that question meant.
So if there's a generic HAL that was going to be shared across other devices, right now what we tend to see is a number of devices basically fork their own copy and put that in their device directory. But that ends up just with a lot, like, the audio HAL, for example, like where we borrowed the Yukawa audio HAL. It would probably be better to have a generic HAL where, we have a project inside of AOSP, its own Git tree, that then different projects could include if they need it.
I see.
But I know the process of adding a new project to the manifest is
the new project, and it'll still need it'll still need somebody from Google side to do all of that, and it needs a user there as well. So that's a whole bunch of problems. But we can do that, but it is an involved process, Yeah, and I guess I would suggest starting off with kernel team at android.com. If you drop us an email, we are very responsive, and we can go from there. And then we can have a public issue tracker even. So I'd love to get people used to that as well, because then it becomes easier for us and for everybody else outside to monitor and track.
Since no other questions, I'll throw a bunch of questions that I never got to in my presentation, and people can bring it back during the BOF or talk about it here. But a couple of questions I had was like, are there any DT bindings that firmware DevLink is not currently processing that people want to see added, except the networking related properties that I'm already aware of? That was one question. And actually, the firmware DevLink help any of your use cases? I've never really heard back on it. Where is it helping? That'll be kind of nice to hear too. Yeah.
So maybe we could sort of take a bit of this time here to plan for the BOF collectively, since we're all already here. Sumit, you had mentioned that you had taken some notes. Do you want to possibly sort of go through that and sort of list it out to people so they can sort of add or possibly sort of suggest other things?
Sure. So we had 10 sessions, and I know that for sure firmware dev-link needs a session. There was more discussion around DMA-buff allocation attribute, but probably that would happen at the GPU mem tracking microconference, and we can get back to it later. The thermal core usage challenge couldn't finish, so we definitely require time for that. I'm not sure about the DM snapshot in user space bit, whether it requires more BOF time, because I didn't see a lot of questions that were there towards the end. Likewise, on the FS stacking with fuse, I'm not pretty sure if there are questions around. I know that the UClampC group ones had questions pending towards the end, so we probably should plan for that. And then the last one, the GKI one, I don't think should need one. So we have about 5, I think, sessions that, and this excludes actually the last 3 sessions because I didn't get to tag them accordingly. So I'm not sure about speculative page faults. Do we need a session? Likewise for the, drivers and Android drivers and Rust, I didn't see many questions that would drive any discussion. So I don't know if that's, let me just list the ones I feel need one in the shared notes, and we can see.
For speculative page faults, if I do plan to participate to the Android BOF after 9:15, so in case there are questions about it.
Okay, sure. I'll make a note. Thank you. So Karim, we could probably just use this document itself and tag what we want to discuss. Let me just start with, okay, let us find a dev link.
And I'm okay with going in the order we talked about too.
Yeah, we could do that, or if there are only a few, then we could probably try to work around stuff, because I know that I also would like to attend the C group around the DMA-buff thing that's happening on Friday, and I'm sure there will be a few others.
Right, yeah. I mean, on the ones we do decided to talk, it's okay to go by order by me. Put another way, I prefer later time.
Okay.
I'd be up when it starts, but my brain will probably work later.
Okay.
Yeah.
All right, so just so if for in the interest of time here, just so we're sort of at the end of the micro conference here, people are sort of more than free to sort of stick around, but I'm not guaranteed that the recording will continue after 11 Pacific. So I would like to thank everybody for participating. This has been great. We look forward to welcome you again on Friday. And we again thank our sponsors and the organization committee on behalf of Todd, John, Rick, Sumit, Amit, and myself. I'd like to thank you all and look forward to continuing this conversation on Friday. So I will turn my webcam off here and the audio off, but if you want to sort of continue talking or chatting, I'm all for it. Again, I just not guarantee that any of that will continue being recorded.
Sure, Karim.
Sumit, I'm assuming we'll kind of time bound the BOFs too, right?
Yes, I think we should. So
Yeah.
I'll just try to see if the other MC folks are here. We can do this offline also. So
Yeah, we can do this. I just kind of wanted to make a request to still time bound so that we give everybody a chance. That's all.
Yes, of course.
Thank you, Sumit.
No problem. Thanks.